Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam, Om Swastiastu, Namo Buddhaya, salam kebajikan, salam sejahtera untuk kita semua. Ibu Bapak yang saya hormati, terutama para narasumber dari seminar internasional yang sedang dan akan kita laksanakan pada pagi hari ini. Tentu saya juga ingin menyampaikan terima kasih untuk Ibu Sachiko Takeda yang berkenan hadir langsung. Sebagaimana tadi disampaikan, dilaporkan oleh Bu Direktur bahwa kerjasama ini atau kegiatan ini tidak mungkin kita lakukan tanpa inisiasi bersama JICA pada waktu itu. Ibu Bapak sekalian yang saya hormati, terutama rekan-rekan dari BMKG, Pak Deputi dan tim, saya ingin menyampaikan permohonan maaf Pak Menteri PUPR yang sejak lama merencanakan untuk bisa hadir langsung membuka acara ini. Namun beliau harus berada di tempat lain yang tidak ada pilihan. Jadi oleh karena itu beliau berkali-kali memastikan agar saya bisa mewakili menyampaikan sambutan beliau pada pagi hari ini. Bahkan harusnya hari ini saya di Jayapura, tapi diminta kembali pulang untuk membuka acara ini. Oleh karena itu izinkan saya membacakan sambutan yang semula akan disampaikan oleh beliau. Yang saya hormati Kepala Badan Meteorologi, Klimatologi, dan Geofisika, Ibu Profesor Dwi Korita Karnawati, yang dalam hal ini diwakili oleh Deputi Infrastruktur, Pak Michael, makasih banyak. Para pejabat tinggi media dan pratama, khususnya dari Kementerian Pekerjaan Umum dan Perumahan Rakyat dan BMKG, para pembicara kunci, saya tadi duduk bersama Prof. Gunawan, saya tadi juga duduk bersama Pak Tetsu Kubota dari Hiroshima University, dan tentu narasumber yang lain dan moderator. Para generasi muda PUPR, BMKG, dan seluruh peserta dan narasumber yang saya banggakan, hadirin yang berbahagia. Pertama-tama izinkan saya mengiringi Bapak Ibu semua untuk memanjatkan puji dan syukur kepada Allah Subhanahu wa Ta'ala, Tuhan yang Maha Esa, atas hidayah dan karunia-Nya yang tidak henti-hentinya, sehingga pada pagi hari ini kita dapat hadir di acara seminar internasional dan peluncuran peta zona iklim sebagai rangkaian kegiatan Hari Habitat Dunia dan Hari Kota Dunia dengan tema Jaga Iklim, Jaga Masa Depan dalam keadaan sehat walafiat. Bapak Ibu hadirin yang saya hormati, perubahan iklim bukan lagi merupakan ancaman di masa depan. Kita sudah merasakannya, kita sudah menyadarinya, ini sudah merupakan kenyataan yang dampaknya sudah mulai kita rasakan dan akan terus memburuk apabila tidak dilakukan mitigasi yang tepat. Kita sudah merasakan suhu udara semakin panas, kota di pesisir perlahan mulai tenggelam, bencana alam terkait iklim semakin sering terjadi, dan menyebabkan kerugian hingga triliunan rupiah. Dan yang paling utama, kualitas hidup kita terus menurun. Pemerintah Indonesia berkomitmen untuk melawan pemanasan global dengan turut meratifikasi persetujuan Paris atau Paris Agreement tahun 2015 lalu. Pemerintah Indonesia terus berkomitmen mengurangi emisi gas rumah kaca, yakni pengurangan emisi gas rumah kaca nasional dari 29% menjadi 31,80% dengan usaha sendiri, dan dari 40% menjadi 42,3% dengan bantuan internasional. Kita tetap optimis bahwa target ini dapat dicapai pada waktunya di tahun 2030 melalui kolaborasi di antara pemangku kepentingan energi serta pengurangan emisi. Dalam Peraturan Pemerintah Nomor 16 Tahun 2021 tentang Peraturan Pelaksanaan Undang-Undang Bangunan gedung diwajibkan untuk menghemat energi sebesar 25% selama operasinya. Berkaitan dengan hal tersebut, Kementerian Pekerjaan Umum dan Perumahan Rakyat telah menerbitkan Peraturan Menteri PUPR Nomor 21 Tahun 2021 tentang penilaian kinerja bangunan hijau. Dalam peraturan ini, potensi penghematan energi dapat dilakukan melalui penerapan strategi iklim mikro dan pendinginan pasif sebelum menerapkan peralatan mechanical electrical yang hemat energi. Bangunan yang memenuhi persyaratan ini akan mendapatkan nilai yang relatif tinggi. Di sisi lain, beberapa negara di dunia, baik negara maju maupun negara berkembang, telah memetakan zona iklim mereka untuk desain bangunan gedung yang berkelanjutan. Dengan demikian, kita juga menyediakan atau mendapat meraih potensi penghematan energi untuk masing-masing zona. Mereka juga menyediakan data cuaca standar untuk keperluan tersebut. Saat ini, kita memiliki zona iklim untuk potensi pendinginan pasif dan data cuaca standar. Hal tersebut terrealisasi berkat kolaborasi yang baik antara kami, Kementerian Pekerjaan Umum dan Perumahan Rakyat, Badan Meteorologi, Klimatologi, dan Geofisika, Kagoshima University, dan Hiroshima University, tentu dengan dukungan penuh dari Japan International Cooperation Agency, JICA. Data ini akan diluncurkan secara resmi hari ini, sehingga dapat digunakan dan bermanfaat bagi pengembangan infrastruktur nasional kita. Bapak, Ibu, dan generasi muda PUPR yang saya banggakan, berbicara tentang bangunan berkelanjutan, bangunan tradisional Indonesia diyakini sebagai bangunan yang responsif terhadap iklim. Mereka menerapkan strategi pendinginan pasif tertentu yang terbukti mampu menciptakan lingkungan termal dalam ruang yang sesuai untuk daerah tropis tanpa bantuan peralatan mekanis. Ibu bapak sekalian yang saya banggakan, para generasi muda yang menjadi peserta aktif dan menjadi pelaku utama pada acara ini, bahwa kata kunci dari tema Hari Habitat dan Hari Kota Dunia tahun ini, yaitu terkait climate, heritage, and youth. Oleh karena itu, maka menjadi penting untuk belajar dari masa lalu demi masa depan yang lebih baik, terutama bagi para generasi muda. Beberapa isu penting dari arsitektur tradisional vernakular perlu diangkat. Pada saat yang sama melakukan inovasi teknologi untuk pengembangan bangunan berkelanjutan. Teknologi material, desain adalah beberapa inovasi yang terinspirasi oleh bangunan tradisional dengan mempertimbangkan kondisi iklim yang berbeda. Sistem manajemen energi juga harus diadopsi. Jika perlu, bahkan sistem bangunan pintar juga dapat diterapkan sesuai dengan Peraturan Menteri PUPR Nomor 10 Tahun 2023 tentang bangunan gedung cerdas. Bapak Ibu hadirin yang saya hormati, inovasi adalah salah satu kunci penting untuk mencapai target pembangunan yang berkelanjutan, termasuk di dalamnya pembangunan infrastruktur kita. Sebagaimana tema utama seminar kita pada hari ini, PAVING OUR SUSTAINABLE FUTURE, Innovation in Climate Resilience, kita harus terus melakukan inovasi termasuk di sektor bangunan gedung kita. Oleh karena itu, saya sangat mengapresiasi inovasi yang dihasilkan dari kolaborasi internasional antara kita semua, Kementerian PUPR, BMKG, Kagoshima University, dan Hiroshima University. Ini sungguh membanggakan. Inovasi ini kita yakini dapat menjadi dasar penting bagi pengembangan infrastruktur bangunan gedung yang berkelanjutan di masa mendatang. Oleh karena itu, sekali lagi saya menyampaikan terima kasih yang sebesar-besarnya kepada BMKG, Kagoshima University, dan Hiroshima University atas kolaborasi luar biasa dalam mengembangkan zona iklim untuk potensi pendinginan pasif dan data cuaca standar. Tentu saya juga sangat berterima kasih kepada JICA yang sepenuhnya mendukung inovasi ini. Hal ini merupakan contoh baik dari kolaborasi internasional dengan tujuan yang jelas dan hasil yang signifikan dalam menghasilkan inovasi yang bermanfaat bagi pengembangan infrastruktur di Indonesia. Saya juga ingin menyampaikan terima kasih kepada para pembicara kunci atas kesediaannya untuk berbagi pengetahuan berharga dalam seminar ini. Oleh karena itu, maka pada kesempatan yang baik ini, kita yang hadir pada kesempatan yang baik dan tentu dengan silaturahmi ini mudah-mudahan hal-hal baik yang nanti akan disampaikan diberikan, ditularkan oleh para narasumber dapat membuat kita lebih yakin bahwa kita dapat berkolaborasi dengan baik. Akhir kata, saya berharap data yang kita luncurkan hari ini dapat digunakan oleh publik demi pembangunan infrastruktur di Indonesia dan peningkatan kualitas hidup kita semua. Saya juga berharap seminar hari ini akan memberikan pencerahan kepada kita dan memberikan manfaat bagi penyelenggaraan infrastruktur yang berkelanjutan dan pembangunan yang kita harapkan. Dengan mengucapkan Bismillahirrahmanirrahim, secara resmi kita buka bersama acara seminar internasional ini dan nantinya juga akan dilanjutkan dengan peluncuran peta zona iklim sebagai rangkaian kegiatan Hari Habitat Dunia dan Hari Kota Dunia 2024. Semoga Allah Subhanahu wa Ta'ala selalu memberikan kita kekuatan dan kesabaran untuk bisa terus bekerja, memberikan manfaat bagi masyarakat. Wabillahi taufik wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Menteri Pekerjaan Umum dan Perumahan Rakyat M. Basuki Hadi Mulyono. Ibu Bapak sekalian, pada kesempatan yang baik ini saya juga ingin menyampaikan permohonan maaf dari Bu Dirjen, Bu Diana, yang juga harus hadir di NTT karena ada peresmian yang akan dilakukan oleh Bapak Presiden. Oleh karena itu tidak mengurangi rasa hormat Pak Menteri, rasa hormat Bu Dirjen, kita lakukan ini dengan penuh kebanggaan, dengan kolaborasi yang baik di antara kita. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Mohon berkenan Bapak untuk tetap berada di atas panggung karena tentunya pada saat ini kami akan mengundang Bapak Muhammad Zainal Fatah selaku Sekjen Kementerian PUPR untuk nantinya dapat melaksanakan peluncuran peta zona iklim. Namun sebelumnya kami ucapkan terima kasih banyak atas sambutannya Bapak dan tibalah saatnya Bapak dan Ibu kita memasuki acara peluncuran peta zona iklim untuk pendinginan pasif dan data iklim standar dalam pembangunan gedung berkelanjutan. Peluncuran peta ini akan dilaksanakan oleh Bapak Sekjen PUPR, tentunya bersama dengan Deputi Bidang Infrastruktur, Meteorologi, Klimatologi, dan Geofisika BMKG. Mengundang dengan hormat Bapak Michael Andreas Purwoadi, berkenan untuk dapat mendampingi Bapak. Serta juga kami akan mengundang kepada Bapak Marjuki M.Sc selaku PLT Kepala Pusat Layanan Informasi Iklim Terapan BMKG, mewakili Deputi Klimatologi. Kami pun mengundang kepada Insinyur Dian Irawati MT selaku Direktur Bina Teknik Permukiman dan Perumahan Direktorat Jenderal Cipta Karya. Dan juga kami mengundang, would like to invite Mrs. Takeda Sachiko as Director of JICA Indonesia. And also would like to invite Professor Tatsu Kubota from Hiroshima University. Baik, selanjutnya kami mohon kesediaan Bapak Ibu untuk berkenan menempati posisi di atas panggung. Baik, hadirin, selanjutnya adalah momen yang sudah kita tunggu-tunggu. Untuk secara resmi meluncurkan peta ini sudah bersama dengan Bapak Sekjen dan Bapak Deputi yang akan menekan tombol peluncuran pada layar di depan Bapak. Mohon bersiap terlebih dahulu Bapak, namun jangan dulu ditekan. Boleh bersiap terlebih dahulu Bapak, izin mohon berkenan. Jangan dulu ditekan tentunya Bapak dan Ibu. Mari kita hitung mundur bersama. 5, 4, 3, 2, 1. Silakan ditekan tombolnya. Dan selamat. Peta zona iklim untuk pendinginan pasif dan data iklim standar secara resmi diluncurkan. Terima kasih banyak kepada Bapak Sekjen dan juga Bapak Deputi atas kehormatan meluncurkan peta ini. Terima kasih pula kami ucapkan kepada seluruh stakeholder yang telah mendukung dalam peluncuran peta iklim ini. Kami berharap peta pendinginan pasif dan data iklim standar ini akan membawa manfaat yang besar bagi kita semua. Dan selanjutnya, kami mohon Bapak tetap berada di tempat, dikarenakan kita akan menyaksikan penyerahan buku sebagai bentuk simbolis kerjasama antara PUPR dan BMKG. Penyerahan buku berjudul Bina Cipta Karya Bersama Iklim diserahkan oleh Bapak Sekjen PUPR kepada Bapak Deputi Bidang Infrastruktur Meteorologi, Klimatologi, dan Geofisika BMKG. Mohon untuk tetap berada di tempat Bapak, kita akan berfoto bersama terlebih dahulu. Bapak Ibu yang mendampingi kami silahkan untuk dapat berdiri lebih dekat. Dan tentunya akan bersama kita abadikan momen berbahagia ini. Bapak Ibu boleh kita iringi dengan tepuk tangan yang paling meriah sekali lagi tentunya untuk kita semua. Baik, dicukupkan kami ucapkan terima kasih banyak Bapak dan juga Ibu. Penuh dengan hormat kami persilahkan Bapak dan Ibu untuk dapat kembali ke tempat semula. Sekali lagi kami mengucapkan selamat atas telah resminya diluncurkan peta zona iklim untuk pendinginan pasif dan data iklim standar secara resmi. Bapak Ibu hadirin yang berbahagia, pada kesempatan ini kami pun juga akan menampilkan sebuah video yang sangat informatif tentunya mengenai peta pendinginan pasif dan data iklim standar yang menjadi bagian penting dalam proses pembangunan gedung berkelanjutan. Video ini akan memberikan wawasan mengenai bagaimana penggunaan strategi pendinginan pasif dapat mengurangi konsumsi energi dan bagaimana data iklim yang akurat memainkan peran krusial dalam perencanaan pembangunan gedung yang ramah lingkungan. Mari kita bersama-sama menyaksikan dan juga memahami lebih lanjut dalam bagaimana proyek ini dapat berkontribusi terhadap pembangunan yang lebih hijau dan berkelanjutan. Selamat menyaksikan.
Hingga saat ini, zona iklim di Indonesia mengikuti zona iklim Kopan yang membagi wilayah Indonesia ke dalam 3 zona iklim utama, yaitu hutan hujan tropis, monsun, dan sabana. Peta ini kurang mencukupi sebagai dasar perancangan bangunan gedung karena hanya mendasarkan pada curah hujan dan sebaran vegetasi. Kementerian Pekerjaan Umum dan Perumahan Rakyat bersama Badan Meteorologi, Klimatologi, dan Geofisika bekerja sama dengan Kagoshima University dan Hiroshima University Jepang mengembangkan peta zona iklim baru untuk Indonesia melalui kegiatan Science and Technology Research Partnership for Sustainable Development atau SATREPS dan didukung oleh Japan International Cooperation Agency atau JICA. Data dari 106 stasiun iklim yang terdiri dari suhu udara, kelembapan udara, kecepatan angin, cloud cover atau tutupan awan, radiasi matahari, curah hujan, tekanan udara, diambil dari 106 stasiun iklim BMKG di seluruh Indonesia. Data tersebut diolah, dianalisis, dan dikembangkan dengan metode yang sudah diterima secara luas, sehingga menghasilkan zona iklim baru. Zona iklim baru itu adalah zona iklim khatulistiwa, subkhatulistiwa, dataran tinggi, dataran sangat tinggi, monsun, submonsun, sabana, dan subsabana. Peta zonasi iklim ini berisi informasi lengkap tentang kondisi iklim di setiap wilayah, termasuk kota-kota. Peta zonasi iklim ini juga dilengkapi dengan potensi pendinginan pasif untuk masing-masing zona iklim. Sehingga, perencana dan perancang bangunan gedung dapat merancang bangunan gedung yang responsif terhadap iklim, mempertahankan kenyamanan di dalamnya, efisien dalam pemanfaatan energi, dan berkinerja tinggi. Salah satu cara merencanakan dan merancang bangunan gedung yang nyaman, efisien, dan berkinerja tinggi adalah dengan memanfaatkan perangkat lunak simulasi kinerja bangunan gedung. Salah satu masukan utama dan penting untuk simulasi adalah data iklim standar. Tidak seperti data iklim standar sebelumnya, data iklim standar hasil kolaborasi ini berasal dari pengukuran langsung stasiun iklim BMKG yang tersebar di seluruh Indonesia. Data iklim standar dapat diunduh di website PUPR dan BMKG. Kini, peta potensi pendinginan pasif dan standar weather data dapat dimanfaatkan secara terbuka oleh publik untuk perencanaan dan perancangan bangunan gedung berkinerja tinggi menuju infrastruktur berkelanjutan demi masa depan yang lebih cerah untuk generasi mendatang.
Boleh kita berikan tepuk tangan yang paling meriah untuk proyek ini yang semoga dapat berkontribusi terhadap pembangunan yang lebih hijau dan berkelanjutan. Baik Bapak Ibu hadirin yang berbahagia, acara selanjutnya adalah pidato utama dari Kepala BMKG yang akan disampaikan oleh Bapak Dr. Engineer Michael Andreas Purwoadi selaku Deputi Bidang Infrastruktur Meteorologi, Klimatologi, dan Geofisika BMKG. Kepada Bapak Dr. Michael Andreas Purwoadi, kami persilahkan.
Yang kami hormati Bapak Menteri Pekerjaan Umum dan Perumahan Rakyat, Bapak Dr. Insinyur Haji Muhammad Basuki Hadi Mulyono, M.Sc. PhD, yang saat ini diwakili oleh Bapak Sekretaris Jenderal Kementerian Pekerjaan Umum dan Perumahan Rakyat, Bapak Insinyur Muhammad Zainal Fatah. Yang kami hormati Ibu Direktur Bina Teknik Pemukiman dan Perumahan, Ibu Insinyur Diani Irawati MT. Our guest, Ms. Takeda from JICA, Profesor Gunawan Cahyono, Profesor Kubota from Hiroshima University, para pejabat tinggi media dan Pratama beserta seluruh jajarannya di lingkungan Kementerian Pekerjaan Umum dan Perumahan Rakyat, para pejabat tinggi Pratama, administrator dan pengawas BMKG Pusat dan Daerah yang hadir pada pagi hari ini, dan Bapak Ibu seluruh tamu undangan yang kami hormati. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, salam kebajikan. Salam sejahtera dan selamat pagi bagi kita semua. Pertama-tama marilah kita panjatkan puji dan syukur kehadirat Allah Subhanahu wa Ta'ala karena atas limpahan rahmat dan karunia-Nya pada pagi hari ini kita dapat bertatap muka dan hadir bersama-sama guna mengikuti acara peluncuran peta potensi pendinginan pasif dan data iklim standar yang tadi baru saja dilakukan dan seminar Internasional Habitat dengan tema PAVING OUR SUSTAINABLE FUTURE Innovation and Climate Resilient Habitat. Kami mohon maaf bahwa Ibu Kepala BMKG, Profesor Insinyur Dwi Korita Karnawati, M.Sc. PhD, berhalangan hadir. Mohon izin kami akan membacakan naskah pidato utama beliau. Bapak Ibu hadirin yang berbahagia, hari ini kita berkumpul dalam sebuah acara yang sangat penting dan bermakna, yakni Seminar Internasional Habitat dan Peluncuran Peta Potensi Pendinginan Pasif dan Data Iklim Standar yang diinisiasi oleh kerjasama antara Kementerian PUPR dan BMKG, juga dengan Universitas Hiroshima dan Kagoshima. Kegiatan ini bukan sekedar seminar biasa, tetapi di dalamnya dilakukan peluncuran sebuah produk yang dapat dimanfaatkan dalam bidang bangunan, yaitu peluncuran peta potensi pendinginan pasif dan data iklim standar. Sebagai lembaga yang diberi mandat untuk memberikan informasi meteorologi, klimatologi, dan geofisika yang akurat dan dapat diandalkan, BMKG memiliki peran krusial dalam memberikan layanan informasi iklim. BMKG tidak hanya bertanggung jawab untuk menyampaikan informasi, tetapi juga untuk memastikan bahwa informasi tersebut dipahami dengan baik oleh masyarakat sehingga dapat dimanfaatkan dengan sebaik-baiknya. Hadirin yang berbahagia, perubahan iklim menjadi tantangan global terpenting bagi umat manusia saat ini. Laporan dari berbagai lembaga dunia, di antaranya World Meteorological Organization atau WMO, Intergovernmental Panel on Climate Change, IPCC, dan United Nations Framework Convention on Climate Change atau UNFCCC, menyatakan bahwa perubahan iklim akan terus terjadi dalam beberapa dekade mendatang apabila tidak dilakukan aksi mitigasi. Dampak negatif yang telah ditimbulkan oleh perubahan iklim menuntut perlunya respons global untuk melakukan aksi mitigasi dan adaptasi. Diperlukan kesadaran yang masif dari kita semua dan seluruh masyarakat dalam berbagai tingkatan yang disertai dengan aksi iklim yang nyata dan terukur dalam mewujudkan target Perjanjian Paris, yaitu membatasi peningkatan suhu rata-rata global di bawah 1,5 derajat dari tingkat pra-industri dan mendukung pencapaian Sustainable Development Goals atau SDG ke-13, yaitu Climate Action. Meningkatnya tren suhu udara global akibat perubahan iklim telah menyebabkan konsekuensi negatif di berbagai sektor, di antaranya sektor bangunan gedung. Dalam beberapa dekade terakhir, untuk mencapai kenyamanan termal bagi penghuni dalam ruangan gedung, didominasi oleh penggunaan pendingin aktif atau air conditioner, AC, yang menyebabkan konsumsi energi bangunan meningkat. Oleh karena itu, strategi adaptasi perubahan iklim yang perlu dikembangkan dalam meningkatkan kemampuan kinerja bangunan untuk mencapai kenyamanan termal dengan menggunakan energi secara lebih efisien. Seluruh undangan yang kami hormati, jika dilihat dari rangkaian perjalanan kegiatan ini, BMKG bergabung dalam kelompok penelitian iklim dalam kerjasama Satrep dalam kerangka Development of Low Carbon Affordable Apartment in the Hot and Humid Climate of Indonesia towards Paris Agreement 2030. Secara spesifik, BMKG bergabung dalam kelompok penelitian iklim Satrep yang dimulai pada tahun 2021. Dalam hal ini, BMKG mengirimkan 2 perwakilan mahasiswa doktoral S3 di 2 universitas di Jepang, yaitu di Kagoshima University dan Hiroshima University. Hasil dari penelitian-penelitian tersebut diantaranya adalah pengembangan zona iklim untuk pendinginan pasif dan data iklim standar atau typical meteorological year yang di-launching tadi pagi oleh Kementerian PUPR bersama BMKG. Kumpulan data iklim memainkan peranan penting untuk menjadi acuan dalam mendesain bangunan baru dan menilai kinerja bangunan yang sudah ada saat ini. Beberapa teknologi dan inovasi pendinginan pasif dalam konsep green building seperti comfort ventilation, nighttime ventilation, dan evaporative cooling yang mempertimbangkan beberapa unsur iklim seperti suhu, kecepatan angin, kelembapan relatif, dan unsur iklim lainnya menjadi solusi menjanjikan yang dapat diterapkan untuk mencapai kenyamanan termal di dalam ruangan tanpa memerlukan konsumsi energi bangunan yang berlebih. BMKG dan Kementerian PUPR bekerja sama dalam menciptakan inovasi berupa produk peta zona iklim untuk pendinginan pasif dan produk data typical meteorological year atau TMY di Indonesia. Peta zona iklim di Indonesia saat ini dibagi ke dalam 8 zona iklim baru beserta penilaian potensi pendinginan pasifnya. Meliputi zona iklim 1A, ekuator, 1B, sub-ekuator, 2A, dataran tinggi, tropis, 2B, dataran sangat tinggi tropis, 3A, daerah monsunal, 3B submonsunal, 4A savana, dan 4B subsavana. Sedangkan data typical meteorological year yang dikembangkan berasal dari data-data 106 lokasi stasiun pengamatan cuaca dan iklim BMKG yang tersebar di seluruh Indonesia. Informasi peta zona iklim untuk pendinginan pasif dan data typical meteorological year di Indonesia akan dibahas lebih rinci di dalam seminar ini. Hadirin yang berbahagia, pada akhirnya kami mengucapkan terima kasih kepada semua pihak yang telah mendukung kerjasama lintas kementerian ini, Kementerian PUPR, Hiroshima University, Kagoshima University, M.Sc, dalam proses penciptaan inovasi penelitian Pasif Cooling Potential Map and Standard Weather Data pada tahun 2024 ini. Semoga layanan informasi yang diberikan ini dapat memberikan wawasan dan ilmu pengetahuan serta memenuhi kebutuhan dan menjawab tantangan yang dihadapi oleh para pengguna serta stakeholder di sektor bangunan di Indonesia. Seluruh undangan yang kami hormati, semoga acara ini menjadi titik awal bagi kolaborasi lebih kuat antara pemerintah, masyarakat, dan generasi muda, sehingga kita dapat memastikan keberlanjutan aksi iklim di masa mendatang. Akhir kata, saya ucapkan terima kasih kepada seluruh panitia, seluruh peserta, dan semua pihak yang telah mendukung terselenggaranya acara ini. Semoga seminar internasional Habitat dan peluncuran peta potensi pendinginan pasif dan data iklim standar ini berjalan sukses dan membawa dampak positif yang nyata bagi para pengguna serta stakeholder di sektor bangunan Indonesia. Amin. Sekian dan terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Kepala Badan Meteorologi, Klimatologi, dan Geofisika, Profesor Insinyur Dwi Korita Karnawati, M.Sc, PhD. Terima kasih.
Terima kasih kami ucapkan kepada Bapak Michael Andreas Purwoadi atas pidato yang telah disampaikan. Baik Bapak Ibu, mohon izin kami akan menyampaikan bahwa pada saat ini kita akan memasuki agenda berikutnya, yaitu talk show penjelasan peta zona iklim. Dan juga kita akan mendengarkan penjelasan mengenai peta zona iklim untuk pendinginan pasif dan data iklim standar. Sesi ini pun akan disampaikan oleh Bapak I. Dewa Gede Arya Putra dari BMKG dan Bapak Muhammad Nur Fajri Al-Fatah dari Kementerian PUPR. Untuk itu, izinkan kami untuk dapat memperkenalkan narasumber kita pada pagi hari ini dan izinkan kami pula untuk dapat membacakan profil singkat dari. Yang pertama adalah Bapak I. Dewa Gede Arya Putra yang merupakan seorang perekayasa di Pusat Standarisasi Instrumen Meteorologi, Klimatologi, Geofisika, BMKG dan keahliannya meliputi pemrograman dan pengolahan data iklim. Bersama tim proyek SATREPS, beliau mengembangkan zona iklim untuk teknik pendinginan pasif dan data iklim standar untuk simulasi bangunan di Indonesia ketika beliau studi doktoral di Kagoshima University. Dan profil singkat dari narasumber kedua kita adalah Bapak Muhammad Nur Fajri Al-Fatah yang merupakan perekayasa di Kementerian Pekerjaan Umum dan Perumahan Rakyat atau PUPR. Dan beliau pun telah melakukan berbagai proyek penelitian dan pengembangan yang berfokus pada bangunan hemat energi, khususnya dalam strategi pendinginan pasif. Dan saat ini beliau memimpin proyek SATREPS, sebuah kolaborasi internasional antara PUPR dan JICA yang bertujuan untuk mengembangkan model bangunan rumah susun rendah karbon yang terjangkau di iklim tropis panas dan lembab di Indonesia. Hadirin yang kami bahagiakan, tentunya mari bersama dapat kita sambut kedua narasumber kita, Bapak I. Dewa Gede Arya Putra dan Bapak Muhammad Nur Fajri Al-Fatah.
Terima kasih.
Selamat datang Bapak I. Dewa Gede Arya Putra dan juga Bapak Muhammad Nur Fajri Al-Fatah. Izin supaya lebih akrab lagi, mungkin saya akan memanggil kepada Bapak Dewa. Cukup dengan panggilan Bapak Dewa saja atau harus lengkap Pak panggilannya?
Cukup Dewa saja Mbak.
Cukup Pak Dewa saja, tapi kalau panggil Pak Dewa ini tentunya tidak akan kena somasi kan ya Pak ya? Baik, dan juga kita setelah bersama dengan Bapak Nur Fajri Al-Fatah yang tentunya nanti akan kita tanyakan mengenai peta zona iklim dan juga tentunya data iklim standar. Izin Bapak, mungkin kita dapat bergeser terlebih dahulu agar nantinya mungkin para rekan-rekan dan juga peserta sekalian dapat melihat paparan dan juga jawaban Bapak lebih jelas di layar. Mari Bapak.
Terima kasih.
Baik, pertama-tama Bapak Ibu, dalam sesi talk show ini kita akan memberikan pertanyaan terlebih dahulu sesuai dengan tema kita hari ini. Bapak Dewa, izin mungkin kita akan langsung bertanya pada pertanyaan kita yang pertama mengenai pembuatan peta potensi ini. Kira-kira apakah yang menjadi latar belakang dalam pembuatan peta potensi pendinginan pasif dan juga data iklim standar ini, Bapak? Apakah kita memang sebelumnya belum mempunyai peta dan data ini?
Ya, izin Bapak Deputi, Bapak Sekjen, izin kami sampaikan bahwa sebelumnya kami di sini bekerja sama di bawah BMKG, kemudian PUPR, Kagoshima University dan Hiroshima University Di sini kami mencoba mengembangkan zona iklim dan data iklim standar. Jadi sebelumnya di Indonesia menggunakan zona iklim Koppen ya, karena zona iklim Koppen itu sebenarnya tersedia secara global. Namun di sini zona iklim Koppen itu masih terdapat kekurangan karena dibuat berdasarkan vegetasi, curah hujan dan temperatur. Jadi kami coba mempropos zona iklim baru yang di sini dapat digunakan untuk keperluan desain bangunan. Dan sebenarnya juga data iklim standar itu juga sudah tersedia secara global yang disediakan oleh IWEC dan One Climate Building. Namun data tersebut masih berdasarkan model iklim. Jadi di sini kita mencoba membuat data standar itu berdasarkan dari data observasi yang ground station yang ada di Indonesia yang diobservasi oleh stasiun BMKG, dan kita juga melakukan data quality control juga untuk membuat data iklim standar tersebut.
Baik Bapak, mungkin juga selanjutnya bisa diceritakan sedikit saja mengenai apa itu sebenarnya peta zona iklim untuk pendinginan pasif ini. Kemudian juga bagaimana proses zonasi ini dan juga mungkin ada metode-metode yang digunakan untuk membuat peta zona iklim?
Ya, jadi data iklim standar dan zona iklim ini dibuat dari data 106 stasiun. Bisa dilihat di sini yang segitiga biru itu adalah stasiun BMKG yang mencatat unsur-unsur iklim. Di sini ada unsur iklim total cloud cover, kemudian missing ratio, kemudian precipitation dan sebagainya. Jadi kita menggunakan 8 unsur iklim untuk membuat zona iklim baru ini, karena di sini juga kita melihat topografi wilayah di Indonesia, karena sebaran wilayah di Indonesia juga kadang-kadang ada yang dataran tinggi, kemudian lautan dan kompleks. Jadi kita mencoba menggabungkan dari seluruh unsur iklim dan unsur ketinggian, topografi wilayah, dan terjadilah yang kita buat sekarang itu zona iklim baru.
Baik Bapak, dalam pembuatan peta zona iklim ini apakah pernah ditemukan hambatan ataupun juga kira-kira apa saja tantangannya untuk peta zona iklim ini dan bagaimana Bapak mengatasinya?
Ya, jadi untuk membuat peta zona iklim ini juga kami terdapat beberapa tantangan ya, karena untuk observasi stasiun di sini juga masih terdapat kekurangan untuk unsur solar radiasi ya. Jadi untuk membuat zona iklim ini kita juga menggunakan data reanalisis atau data dari satelit yang digunakan untuk membuat zona iklim ini. Kira-kira seperti itu Mbak.
Baik. Barusan adalah beberapa pertanyaan yang sempat kita tanyakan kepada Bapak Dewa mengenai peta zona iklim. Mungkin kita akan berpindah juga Bapak untuk membahas mengenai data iklim standar. Dan juga mungkin boleh dibantu Bapak untuk menjelaskan singkat kepada kita semua mengenai data iklim standar itu seperti apa dan juga bagaimana metode untuk dapat mengembangkan data iklim standar?
Ya, jadi data iklim standar itu adalah kumpulan data set iklim dengan resolusi jam-jaman yang dikompresi dari 10 tahun menjadi 1 tahun. Jadi di sini dapat dilihat bahwa data iklim standar itu tersedia di website ini, One Climate Building dan dari IWEC 2. Kemudian data iklim standar ini masih menggunakan model ya. Jadi untuk data iklim yang baru ini kita coba buat itu digunakan untuk input simulasi bangunan. Jadi setiap arsitek atau setiap desainer yang ingin merancang bangunan baru, jadi bisa memasukkan data iklim standar ini dan digunakan untuk simulasi komputer atau software, dan itu akan menghasilkan desain yang optimal, bisa memilih desain yang mana yang sesuai dengan iklim di wilayah tersebut. Karena kita ketahui meskipun di wilayah tropis, tapi kadang-kadang suhu di Jakarta dan di Surabaya kadang-kadang berbeda. Jadi data iklim standar ini akan menjembatani bagaimana kita membuat desain itu berdasarkan wilayah di suatu wilayah seperti itu.
Baik Bapak, tadi jika dikatakan bahwa data iklim standar adalah salah satu metode baru untuk membantu pembangunan, kira-kira apakah Bapak sempat menemukan tantangan atau juga hambatan dalam proses pengembangannya Bapak?
Ya, jadi banyak sekali tantangan yang kita dapatkan dalam menjalankan riset ini, terutama karena untuk membuat desain bangunan yang maksimal, jadi kita memerlukan data di lokasi terdekat ya. Sedangkan di sini hanya menggunakan 106 stasiun. Jadi karena wilayah Indonesia itu luas, jadi untuk sementara kita menggunakan data iklim standar di wilayah terdekat. Misalnya kalau di Jakarta itu bisa diwakili oleh stasiun Kemayoran dan stasiun Soekarno-Hatta ya. Jadi kira-kira untuk kerapatan data itu sekarang masih kita menggunakan 106 stasiun. Jadi kira-kira seperti itu Mbak.
Jadi pasti setiap hari ada terus bagaimana solusinya untuk menanggulangi hambatan dan juga tantangan itu ya Bapak ya?
Ya benar Mbak.
Baik, mungkin satu pertanyaan terakhir untuk Bapak Dewa sebelum nantinya saya berpindah kepada Bapak Nur Fajri. Harap bersabar Bapak di sebelah sana. Baik, Bapak Dewa, kira-kira apakah peta zonasi dan juga data iklim standar ini sudah bisa kita katakan sempurna? Jika belum, kira-kira apa yang kurang dan juga apa yang harus masih kita kembangkan di masa depan?
Ya, jadi ya yang kita launching sekarang ini data zona iklim dan TMY versi 1 ya. Datanya sudah tersedia di website BMKG dan PUPR, bisa dilihat di link di atas. Jika memerlukan informasi bisa membuka link di atas ya. Kemudian untuk yang data yang versi 1 ini kita harus mengupdate lagi gitu. Kira-kira karena iklim akan berubah, jadi mungkin setiap 10 tahun atau 20 tahun, 30 tahun kita akan update lagi. Karena semakin panjang datanya, itu akan semakin bagus untuk merepresentasikan sebuah wilayah untuk membangun data iklim. Dan kedepannya juga kita akan mencoba mengkomplemen data typical meteorological year dan zona iklim ini dengan data ekstrim ya. Karena perubahan iklim, jadi semakin banyak kejadian ekstrim yang juga mempengaruhi untuk konsumsi energi bangunan. Jadi kira-kira seperti itu Mbak.
Baik, jadi pastinya tentunya selalu ada metode dan juga cara-cara ke depan untuk kita bisa selalu mengembangkan data iklim ya Bapak. Seperti yang tadi dikatakan bahwa iklim bisa berubah, tapi semoga niat kita untuk memberikan manfaat tidak akan berubah dan selalu sama. Boleh kita berikan sekali lagi Bapak Ibu tepuk tangan yang paling meriah untuk Bapak Dewa. Terima kasih Bapak. Mungkin sekarang saya akan beralih kepada Bapak Muhammad Nur Fajri Al-Fatah. Langsung saja Bapak untuk pertanyaan pertama, saya akan bertanya mengenai seberapa penting kira-kira peta dan data ini untuk pembangunan infrastruktur bangunan gedung di Indonesia dan apakah ada kaitannya Bapak dari peta dan juga data dengan bangunan gedung berkelanjutan di Indonesia?
Iya, terima kasih pertanyaannya. Jadi saya bisa menyampaikan dalam satu hal, bangunan gedung yang dibangun tanpa mempertimbangkan faktor iklim itu akan menjadi bangunan yang sangat tidak efisien dan juga dalam taraf tertentu mungkin tidak nyaman. Jadi kalau kita lihat di sini misalnya ya, mulai dari dasar sampai ke atas kita selalu harus mempertimbangkan iklim. Dari microclimate-nya, bagaimana sekitar bangunan gedung itu harus dirancang memiliki microclimate yang bagus. RTH cukup, kemudian dari desain bangunannya ada orientasi, memastikan tidak ada penetrasi radiasi matahari, sampai kemudian pasif sistemnya, bagaimana ventilasinya, dan sebagainya, sampai kemudian bahkan untuk perencanaan mechanical electrical, untuk perumusan beban pendinginan AC sekalipun itu harus mempertimbangkan faktor iklim setempat. Sehingga mau tidak mau ketika kita bicara keterkaitan antara bangunan gedung dan iklim, saya bisa sampaikan bahwa bangunan gedung yang dirancang tanpa mempertimbangkan faktor iklim akan menjadi bangunan yang tidak berkinerja. Kira-kira seperti itu. Saya kaitannya dengan sustainability, jika kita mempertimbangkan iklim di satu sisi, maka kita akan bisa memastikan bahwa bangunan gedung itu nanti akan mampu menghemat energi dan pada gilirannya adalah mengurangi emisi gas rumah kaca. Kira-kira demikian.
Jadi dapat dikatakan bahwa sangat penting dan juga tentunya berkaitan erat begitu ya Pak antara pembangunan dan juga iklim.
Betul.
Baik, jika dikatakan tadi oleh Bapak Nur Fajri Alfata adalah dari PUPR Bapak, jadi bagaimana Kementerian PUPR ini dapat memanfaatkan peta zona iklim untuk pendinginan pasif dan data iklim standar dalam pembangunan infrastruktur di bangunan gedung pada umumnya, dan kira-kira Bapak sejauh mana untuk peta dan juga data iklim tersebut dapat memberikan dampak dalam pembangunan gedung di Indonesia, terutama pada perumahan emisi gas rumah kaca.
Baik, terima kasih. Ya, mungkin saya akan mengambil contoh apa yang sudah kita lakukan sebelumnya, gitu ya. Kita merancang sebuah rumah susun yang kita konsepkan untuk menjadi rumah susun yang low carbon atau rendah hemat energi. Bagaimana kita melakukannya saat itu? Jadi kita pertama memahami iklim setempat dulu. Kita kumpulkan data iklim selama 20 tahun ke belakang, kita analisis kecepatan anginnya, suhu udaranya, radiasi, sampai kemudian sunpad diagramnya seperti apa, sehingga kita bisa menemukan formula orientasi yang tepat, strategi ventilasi yang tepat, pemilihan material yang tepat, bahkan kemudian teknik shading yang tepat, dan kemudian dengan bantuan simulasi komputer seperti yang kalau kita lihat di layar inilah yang paling kiri warna biru yang cantik itu sebenarnya adalah bantuan komputer untuk mengkalkulasikan bagaimana apa yang terjadi dalam ruangan ketika strategi bukaan A, B, C, D, E digunakan, dan itu semuanya dengan bantuan data iklim. Nah, begitu kemudian ini sudah kita bangun dan kita evaluasi apa yang kita temukan, apa yang kita lihat, ternyata bangunan itu memiliki indoor temperatur yang indoor air quality yang bagus, indoor thermal environment yang bagus. Jadi bahkan ketika tanpa menggunakan strategi ventilasi apapun di dalam ruangan itu bisa lebih rendah hingga 4 sampai 5 derajat Celcius. Artinya kita bisa mengurangi beban pendinginan untuk menggunakan AC. Nah, belajar dari ini Bapak Ibu pasti sudah sangat paham sekali bahwa untuk pembangunan IKN sendiri pun saat ini kita sudah mencoba pendekatan dengan menggunakan simulasi untuk memodelkan bangunan dan diukur kinerja bangunannya seperti apa, dan itu membutuhkan data iklim, dan itulah yang kemudian bagaimana data iklim ini sangat dibutuhkan dan sangat berguna di sektor infrastruktur untuk bangunan gedung, terutama untuk PUPR. Nah, saya ingin menunjukkan simulasi, contoh simulasi bagaimana data ini kemudian dimanfaatkan ya. Nah, ini kalau kita lihat, ini kita menggunakan transis begitu ya. Kemudian di paling kiri ada tipe 9E, itu adalah untuk data iklim yang kita masukkan nanti ada di sana. Kemudian, nah ini data iklimnya nanti dimasukkan, data iklim yang baru saja dikembangkan oleh kolaborasi PUPR dan BMKG. Kemudian ada model radiasinya, dan kita sebelumnya sudah membangun model bangunan gedung yang mau kita simulasikan. Nah, apa yang terjadi kemudian ketika data iklim kita masukkan, ketika kita running simulasi ini, kita akan bisa melihat profilnya. Dalam 1 tahun itu sebenarnya suhunya di dalam ruangan berapa, kelembapan udaranya berapa, kemudian sampai energi yang digunakan dalam kilowatt hour-nya berapa, itu nanti akan terlihat dengan simulasi seperti ini. Apabila kita tidak punya target, misalnya target kita terlalu tinggi, hasilnya terlalu tinggi, maka kita bisa melakukan modifikasi di bangunan gedung. Nah, ini perbandingan antara yang sebelah kanan ini adalah yang data iklim yang baru, yang sebelah kiri adalah yang lama. Bedanya apa? Karena yang lama ini, yang lama yang disampaikan oleh Pak Dewa tadi itu diambil dari One Climate, dan yang tadi EPW yang dari hasil modeling ya, bukan hasil pengamatan. Dan yang kiri itu juga datanya sudah terakhir tahun 2005 yang lalu. Ini adalah data terbaru sampai tahun 2020. Artinya kita bisa melihat efek dari climate change, betul-betul perubahan iklim itu terjadi. Jadi ada beda antara data iklim baru yang kita kembangkan dan yang lama tersedia. Nah, kalau kita lihat kemudian, kita bisa dari hasil simulasi ini, kita bisa melihat Ini contohnya Bapak Ibu, pentingnya data iklim tadi untuk simulasi. Kita bisa mensimulasikan berapa energi yang akan digunakan oleh bangunan gedung dalam 1 tahun. Jadi kalau kita bisa modifikasi lagi di tahap desain, kita bisa memaksimalkan data iklim untuk menghasilkan bangunan gedung yang jauh lebih efisien dan berkinerja tinggi. Demikian. Terima kasih.
Terima kasih untuk Bapak Muhammad Nur Fajri Al-Fatah atas pemaparannya dan juga tentunya telah menjawab dengan baik semua pertanyaan yang telah kami berikan. Mungkin izin Bapak, kami dapat mengkonklusikan bahwa dalam perencanaan pembangunan gedung dibutuhkan, memang betul-betul dibutuhkan peta zona iklim dan juga data iklim standar ini tadi sempat disampaikan untuk mengurangi konsumsi energi secara signifikan begitu ya Bapak, dan juga tentunya pembangunan gedung yang ramah lingkungan. Kami mengucapkan terima kasih kepada Bapak Dewa dan juga Bapak Nur Fajri Al-Fatah yang telah berkenan menjadi narasumber. Bapak Ibu boleh kita berikan sekali lagi tepuk tangan yang paling meriah untuk Bapak I Dewa Gede Arya Putra dan Bapak Muhammad Nur Fajri Al-Fatah. Kami silakan Bapak untuk dapat kembali ke tempat semula. Tentunya juga selain kita berterima kasih kepada kedua narasumber yang telah menjelaskan dengan begitu gamblang mengenai peta zona iklim dan juga data iklim standar, kami juga mengucapkan terima kasih atas dukungan dari para stakeholder dan juga tentulah berkat dukungan dari para stakeholder lahirlah proyek ini yang semoga dapat memberikan manfaat untuk kita semua. Baik hadirin yang kami hormati, selanjutnya kita juga akan mengundang Ibu Takeda Sachiko selaku Director of Japan International Cooperation Agency atau JICA yang akan memberikan sambutannya dan juga tentunya beliaulah yang telah memberikan dukungan penuh dalam pelaksanaan proyek ini. So ladies and gentlemen, at this moment we would like to take a moment to acknowledge and thank one of our key person for their invaluable support, and their contribution and partnerships have been instrumental in ensuring the success in this occasion. It is my pleasure to welcome Ms. Takeda Sachiko as Director of JICA Indonesia to the stage to giving a speech. So please join me everybody to the stage. This is Mrs. Takeda. And for the audience, please give a round of applause.
Selamat siang. Thank you very much for inviting us to this seminar today. I am Sachiko Takeda, Chief Representative of JICA Indonesia office. First of all, I would like to express my sincere appreciation to PUPR and BMKG, as well as to Hiroshima University, Kagoshima University, and other related departments and research institutions for all your efforts and enthusiasm for this research, as well as your kind understanding and cooperation. This project is one of the SATREPS projects. The SATREPS is a program designed to promote international joint research in which both Japanese and partner countries' research institutions work together to create new knowledge and to utilize research outcomes to the benefit of the society. Although there was some temporary suspension due to COVID-19, I am very pleased that the project has produced the significant results presented right now. But overall goal of this project is to contribute to the achievement of the Paris Agreement targets by utilizing the research outcomes. With a population of over 270 million, Indonesia is now a middle-income country and is expected to play a greater role in the world. In this context, it is more important than ever for Indonesia to address the global issues such as climate change. As the population grows, demand for affordable housing is increasing, especially among the middle-class individuals. This project is very important because it aims to contribute to supply of houses which are both energy efficient and affordable. I also would like to stress here that the TMY mentioned in the presentation could not have been created without the cooperation of BMKG. Thanks to TMI, the project has been able to improve the climate zones, which are critical for designing houses with high energy efficiency and low carbon emission and cost. In addition, TMI and improved climate zones will allow us to make more detailed analysis, not only for housing, but also other sectors such as agriculture. Today, everyone is present at this seminar, and I hope PUPR and BMKG continue collaboration to standardize this TMI data as reference data for buildings, and Indonesia will take a major lead in addressing climate change. For that purpose, JICA will be very happy to continue to support this project. Thank you very much. Terima kasih banyak.
And thank you very much again for Ms. Takeda for the speech. Baik Bapak Ibu, selanjutnya kita akan menuju ke sesi berikutnya, yaitu seminar internasional dengan tema Paving Our Sustainable Future, Innovation in Climate Resilient Habitat. Tema Jaga Iklim, Jaga Masa Depan yang menjadi tagline dari Hari Habitat Dunia dan Hari Kota Dunia tahun ini merupakan bentuk dukungan terhadap flagship program UN Habitat, yaitu Rise Up, Resilient Settlements for the Urban Poor, dan sekaligus diharapkan dapat membangkitkan semangat untuk secara aktif berkontribusi dalam upaya adaptasi dan mitigasi terhadap perubahan iklim. Seminar dengan tema Paving Our Sustainable Future, Innovation in Climate Resilient Habitat dapat menjadi momen untuk menghimpun dan menyebarluaskan informasi terkait implementasi dan upaya mewujudkan kota yang berkelanjutan melalui upaya penyebarluasan praktik-praktik ataupun aksi-aksi lokal yang sudah atau sedang dilaksanakan oleh berbagai pihak di tanah air, sekaligus menjadi pendorong bagi para pemangku kepentingan untuk berinovasi dalam meningkatkan keberlanjutan pemukiman perkotaan. Bapak Ibu, sebagai informasi, seminar ini juga akan dibawakan dalam bahasa Inggris, dan juga untuk Bapak Ibu yang bergabung melalui daring, kami silahkan untuk dapat menggunakan fitur interpreter untuk mendapatkan dual bahasa. Ladies and gentlemen, again, thank you very much for being part of our successful launch event. And now, as we transition to the next part of our program, we will dive deeper into a subject with our upcoming seminar. In this session, we will have the opportunity to learn from experts and gain valuable insights on paving our sustainable future, innovation in climate resilient habitat. So let's keep the momentum going as we move forward into the seminar. Everybody please stay tuned and enjoy the session. Ladies and gentlemen, it is also my privilege and my pleasure to welcome you to the International Seminar on Paving Our Sustainable Future, Innovation in Climate Resilient Habitat. And on behalf of the organizing committee, I would like to extend our deepest gratitude to all the distinguished speakers and participants joining us today. So respected guests and participants, we are now gathered here to explore innovative solutions and share insights on how we can build climate resilience habitats for a sustainable future. And this seminar will conclude with a question and answer session. And next session will be a talk show on empowering the next generation to lead initiatives for climate and cultural preservation. We will now begin with our first session. I believe this session will be very interesting since we are going to discuss a collaboration on adaptation and mitigation of climate change in architecture and urban. Our session will be chaired by Mrs. Nur Hamida, an urban climate change specialist from the United Nations or ESCAP, who will guide us through today's discussion. And everybody, let's take a moment to share a brief overview of their impressive background. And here is the profile. Mrs. Nur Hamida has extensive experience in working in the urban sector, particularly on housing, disaster risk management, and resilience. She has an educational background in urban planning and architecture and is currently working for ESCAP on the Urban Act project, or Integrated Action for Low Carbon and Resilient Cities, funded by German government. For your information, this session is 130 minutes, including the 30 minutes discussion, and our moderator, Ms. Nur Hamida, will now preside, and the floor is now open for the discussion. Please welcome Mrs. Nur Hamida.
Thank you very much for the nice introduction. Good morning, Your Excellency, Bapak Secretary General of PUPR, and Bapak Deputy for Infrastructure BMKG, and all the honorable guests from BMKG, PUPR, JICA, and then JZ, Hiroshima University, and all partners attending this seminar in this auditorium and joining us online. So my name is Nur Hamida. It's such honor for me to moderate this international seminar. So on behalf of ESCAP and Urban Act Project, please allow me to congratulate the Ministry of Public Works and Housing and climatological and geophysical agency for the launch of this important work. And this is an important milestone for Indonesia to achieve its climate ambition, especially in energy transition. So without further ado, I would like to invite our keynote speakers to the stage. Mr. Marzuki, M.Sc. from Meteorological, Climatological, and Geophysical Agency. Please come to the stage, Pak. Yeah, please give a round of applause. And then our second speaker is Professor Emeritus Dr. Gunawan Cahyono from Universitas Indonesia, sorry. And then the third keynote speaker is Professor Dr. Tetsu Kubota from Hiroshima University, Japan. Let's give a round of applause. And the next keynote speaker, Dr. Johannes Anhorn from GIZ. Thank you very much, gentlemen, for attending this seminar and sharing your insightful from knowledge, experience, and practice about this important topic on climate change and habitats. I'm citing the IPCC report. Buildings contribute about 21% from the global greenhouse gas emissions, and more than half of it is an indirect CO2 emission from electricity and heat. And citing the third biennial or update report under the UNFCCC framework, Indonesia energy is the second emitter after forest and other land use sector. So I guess this is an important work from by BMKG, PUPR, and supported by Hiroshima and Nagasaki University, and supported by JICA. I think to implement this approach, passive cooling and then microclimate in building at scale can significantly contribute to the reduction of greenhouse gas emission, where Indonesia now have more ambitious target to reduce the greenhouse gas emissions. Also because we, as Indonesian, we live in Indonesia, we are facing the dilemma. We want to adapt to the warming climate, but as a tropical country, we get the direct radiation from sunlight. It's more even throughout the year. So we are facing the dilemma. We want to adapt to the warming climate, but we also want to contribute to the reduction of greenhouse gas emission. So I guess this is an important work. So now we want to hear from the more different perspective on these issues. So perhaps for the first speaker, I'd like to give the opportunity to Pak Marzuki from BMKG. So can you show the bio? Okay. So Pak Marzuki is an acting head of Center for Applied Climate Information Services at BMKG. He has various experience on the agroclimate information and specialist holding for climate field school at national level. He also has several experience on international collaboration in developing climate information system. Furthermore, he published papers in international journals and proceedings. Pak Marzuki, the floor is yours whenever you're ready.
Thank you, everyone. My name is Marzuki. I'm right now I'm acting director for the applied climate in BMKG. In this session, I would like to share regarding the climate change status in Indonesia and its impact. Also, what can BMKG providing for the climate services. This is for the opening slide that I believe that almost all we know, climate change has been occurring since the pre-industrial era, that indicated by the global anomaly temperature increasing sharply since the 1980, and in 2023 WMO state of this year, I mean the 2023 is the hottest year on the record, and the temperature anomaly of the year 2023 is 1.45 degrees Celsius, and we should consider that the Paris Agreement limit to increase the temperature anomaly less than 1.5 degrees Celsius. We should be considered. Okay, and if we look the graph for the temperature change in Indonesia, we can also conclude that this situation in line with the global, I think, the temperature anomaly increasing sharply since the 1970. So it is also our consider to take care of our environment and make adaptation and mitigation. And we take a look for detail. Historical data is based on BMKG observation network. We also see that the trend consistent rising temperature with varying rates in almost all stations in Indonesia. However, if we look in detail for the precipitation, the variable in rainfall pattern affect the effect indicates wet days, annual cycle, monsoon onset, but the trend is a variable. If we look for the extreme rainfall, the increasing number even for the extreme also have a positive trend. It means that every place in Indonesia have more extreme, even frequent than before. And if we project make a projection the temperature in Indonesia with the middle scenario for the concentration of greenhouse gases, we also see that almost all area over Indonesia have a change positives. The value is a vary starting from 1.5 to more than 1.15. This is our dashboard. If you want to see the detail, all of the information regarding the climate change situations status in Indonesia. So you can visit the https://iklim.bmkg.go.id/climate change. All the situation, I think, have an influence for the urbanization. We also know that the economic activity that indicated by gross domestic production triggering the urbanization. So the urbanization also triggering the pollutant. Then pollutants have implied for the greenhouse effect. So I think that's the implications about the urbanization. Then finally we can see right now environmental with the urban heat islands. So the urban heat islands area have relatively higher that temperature compared to the suburban and rural areas, and it's indicated by little vegetation as to the heat island effect. Some factors that influence urban area is increased human activity in urban areas, also the complex geometric structure of the city. That's why we are talking now about the infrastructure versus climate, and also the change of the natural land cover to build up land, high thermal capacity of building materials. This is the greenhouse effect that I said before, and reduce wind speed in urban areas and reduce green open space. So this is important to discuss about the urban heat area islands right now regarding the infrastructure technique. This is for some example that based on the monitoring satellite data of the surface temperature maximum, minimum, and average in 2014, showing the change of the environment that triggering local warming. This is a Jakarta area and some surrounding, I think. over the past 30 years, the urban heat islands effect has been relatively strong. It's indicated by minimum temperature in Kemayoran, Tanjung Priok, Halim, Perdana Kusuma, and Cengkareng has increased starting 0.3 degrees Celsius to 0.75 Celsius in 10 years. So if we make a projection, we also see that confirm the potential trend of urban expansion in the projection up to 2050 may also potential impact the spatial intensification of urban heat island in the future. So this is a study by Kekning Huang et al. 2019, so that the expansion of urban land area will result in average summer daytime and nighttime air temperature increasing by 0.5 to 0.7 in same location. So what BMKG can do regarding that, the effect of the climate change and the impact for the urban area. So following that, we adopt for the global framework climate services that guided from WMO to providing the services for sectoral. So we adopt this framework and we try to downscale to the national framework climate services. So within that, we now currently we already provide for the services for the agriculture. We have several information specifically for the farmer, and also health. We have early warning for the dengue in Jakarta, and so on. And one of important sector, we should provide climate information for the infrastructure. This is BMKG climate information in a nutshell, I think. So it's very brief. We have a climate prediction, early warning for El Nino and La Nina, for drought, high rainfall potential. We have also provided information for anomaly and extreme climate. And for the climate change, we already explained about. We also have a portal to Pasif, climate projection, and so on. And the one important thing now, we develop the climate service for the sectoral service. This is mean that we should have a sectoral partner. We should have a stakeholder that we make a co-development information. So right now we have a program, namely Climate Field School for the farmer. We collaborate with the extension worker and also the local government. We also have a soil water availability, flood potential, dengue outbreak, renewable energy, etc. And what we have done with the SATREP, we have information from the MY and also for the some information for the urban heat island areas. Right now we have difference in land surface temperature during the day, and we also have a vegetation land cover such as the green open space can reduce urban temperatures through the microclimate effect. And this is the new one, I think. At the prototype, we try to provide the we call the Iklim. What's the Iklim? This is information provides up to scale village in form of maps, table, graphics, and wind roses. And also it provides the availability parameter are temperature, wind, solar radiation, relative humidity, precipitation, etc., and pilot projection in the greater Jakarta region. So this is our modality, I think. Dewa has already explained about the observation network of BMKG. This is a station, fixed station that operationally every day, every time with the human. And we also have automated observation network of BMKG. Yeah, this is the automatic, more than 1,200 automatic weather station. But with the automatic ranges, we have more than 6,000, I think, over Indonesia. So this is one-stop climate information that we have. You can visit this portal and make more exploring regarding our information. Then, yeah, that's all my presentation. This is valuable for you, and thanks.
Thank you very much, Pak Marzuki, for the very insightful presentation in terms of the scientific climate and how the implication into the building. 2 points that I highlight that we see that's the impact of climate change. There are several data that you show that is more prevalent. 0.3 to 0.7 in 10 years is quite significant. And there is also another one is the importance of using climate data for infrastructure development. And hopefully one thing that's currently being developed by BMKG, green building Iklim, can be implemented not just in Jakarta, but also the other, especially the other bigger cities in Indonesia. Thank you, Pak. For the next presentation, so we will hear about the what we can learn from the past about vernacular architecture from Professor Gunawan Cahyono. Prof, the floor is yours when you are ready.
Thank you, Ms. Nur. I would like to see in front of me, but yet my eyes was hurt by the light.
Okay.
So I'm sorry.
Prof, I think I forgot to mention.
It's okay. So I will follow Pak Marzuki.
Boleh. I think
Before I start, may I say something? I remember which is very important. Was about 35 years ago in Bali, there was an important seminar on environment. And I remember the speaker was our great professor in Universitas Indonesia, the former Minister of Environment, Emil Salim. He said that the destroyer of environments are engineers. No one can deny that. So in this room, most of us are engineers. He also said that, but in the hand of the engineers, the environment can be safe as well. So we are safe. But I have questions for the floor. Can anybody in this floor stop breathing for 5 minutes? Therefore, the air we breathe in is important, and we have the responsibility to protect our air quality. So this is the jobs of our engineers in meteorology who are concerned about the climate change. Well, my title is Learning the Right and the Wrong Lessons from the Past of Modern Architecture. I cannot deny that I was in that tradition in my education system. Possibly in this room, I am very old. My age is 79 years now. So when I was in that education, it's very old, and possibly some of you haven't been born yet too, but it doesn't matter. So why we learn the right and the wrong lesson? We usually only learn from the best practices, right? So my question is, what are the advantages of learning the right lessons? This is my interpretation. Possibly you don't have to agree with me. Most right lessons are considered the success stories of the best practices which were considered valuable as legacy to be copied or learned for implementation. But whose success is the next question. By learning the right way to do things, the learners gain certain knowledge to the path of success. Of course, it is conditional. The question is, whose right way? We need to be critical, right? Yet, best practices may have concealed the unwanted failure of the must-have avoided lessons, which were possibly equally valuable to be learned. Therefore, we need to also learn the wrong question. So what are the advantages of learning the wrong lessons? My interpretation again, failure could be the mother of success. This is the ancient wisdom of most cultures, I believe. By learning the wrongdoings, we may have better preparation strategy for not fall into the same trap. I think most of you can agree about this. So this is only an illustration to show success story. We all gain the best practices, but we also not to falling into the same trap, right? Modern architecture, some notes for me. Although, when did the modern architecture start? Still debatable. For students of architecture, its widespread may due to some facts. The influential movement of modern architecture will be traced back from the establishment of Bauhaus in Germany in 1920s. Then the famous figures are Walter Gropius, Ludwig Mies van der Rohe, Marcel Breuer, and others, who unfortunately moved to the United States. And then, given their experience, which influenced around the world, including me. Pre-Bauhaus influential figures is Viollet-le-Duc of France, Horatio Greenough, possibly in Germany as well, Louis Sullivan, and Adolf Loos, and others who paved the theoretical foundations for modern architecture. The characteristics of modern architecture is emphasis functions over styles and precedents. So I put into the bracket undermines history. So we mostly forget history in our education. In Indonesia especially, avoid ornaments and decorated facades. Embraces new technologies and industrial products in building materials, which is to some aspect good or good lessons to be learned. And it encourages innovation and modular coordination for fabrication. It's good for fast building process or construction process. but it ignored things which resemble traditions and ratio over feeling. Either or attitude, you need to choose A or B. That kind of attitude. Cost-conscious construction programs, and then search for universal principles or values, undermine particular or specific solutions to design problems. These are the legacy of modern architecture education, possibly around the world. Form follows function, or form functions over style, and avoid ornaments. You can see at the upper left-hand side of this drawing. I just illustrate some of the images. So we encourage to form a universal principles of architecture. He developed a lot of archetypes. Some are practical for special moments, such as when you have disaster. Oh, sorry. What happened? I don't know whether you can see it at the right, left-hand side bottom. These are possibly the right lesson we can learn from modern architecture, the triumphal facts. The phrase form follows function encourages us to focus more on the use values of buildings. This phrase had become the norm of architectural education, which spread in Western occupied colonies, including Indonesia. International style and influential exhibition theme at Modern Museum of Modern Art in New York in 1932, whose effects had dominated the major streets of big cities around the capitalistic world. Thus, flat roof, tall buildings with horizontal floor layers become a common display which cast uniformly the characters of main streets in big cities, possibly around the world as well. So prototypical buildings, especially in housing designs, are rising. The prefabrication of building components, which can increase fastly in a building process. So you can see around the world, similar images appear after the influence of this international style. Prototypical housing design appears around the world as well. And this department, the public work and public housing, developed many prototypes of design. When I was in school studying architecture, I studied many prototypes, which is type 45, type 36, or type 72. And modular coordination, as well as the fabrication system. Modern architecture has housing issues. We know that after the World War II, Europe and Asia needed massive reconstruction for recovery of social order and territorial damages. Housing becomes a major problem to house those who lost shelters. Thus, various housing schemes surfaces to fill the need. Prefabrication, mass-produced or assembly system were thoroughly researched with significant results. Affordable, low-cost, core plus or site and services are the common terms in the subjects of housing courses around the world. See, we can assemble a building very fast, which also, of course, good for the disaster mitigations. But what are the wrong reasons for modern architecture? The undermining subjects. Locality, ignorance of water-based living, and then things traditional or local, building traditions or traditional buildings. So they ignore local wisdom. Don't forget that we are Homo sapiens. Sapiens mean wisdom. Well, we almost forget wisdom, but we encourage intelligence. Also destroys our environmental issues, damages of biodiversity by construction, and add carbon burdens to the environment, particularity of expressions, and then natural power tamed by human capabilities or technological progress. The power of handmade building process are also undermined by modern architecture because mass production, fast construction methods are widespread under industrial developments. Feelings also undermined by modern architectural practice. Informality are not good because some are mostly associated with informality, and then both and attitude. We should not always choose either this or that, but we can have both and. Spontaneous actions in building production, which is the base of vernacular architecture. So the left-hand upper image, we mostly forget the sea. And Indonesia is tanah air. We mostly build upon land rather than sea. Why? Possibly, this is my interpretation as well. The sea cannot be certificated for ownership. And these are most of the picture of the undermine after the modern architecture practices. So local wisdom may help environment. The banner, upper side, right hand, and then the Badui. The Wakatobi is at the left-hand side above. The Badui is the left-hand side bottom. You can see the materials. Here, the pointer doesn't work so well because of the battery probably. These are the shortage of technology or the time management. The air can also go into the building because of the material, but unfortunately, this department also prohibits many buildings or traditional building practices around Indonesia. I experienced when I visited the remote areas of Indonesia, and they are crying because their buildings were considered unhealthy, and it is not a good way for to continue their construction traditions. So I think, we have a challenge for the modern architecture. The influential theoretical works are Architecture Without Architects by Rudowski, which were exhibited in Museum of Modern Arts as well, but 32 years after the exhibition of International Style. Acoustics as the Science of Human Settlement, introduced by Doxiadis, which was published in 1968. Why human settlements? Because other species also build settlement. We know that termites, ants build settlement as well, not only human. And then Housewarming and Culture by Rappaport in 1969. Pattern Language by Christopher Alexander in 79, possibly, 10 years later. Complexity and Contradiction in Architecture by Robert Venturi. The Language of Postmodern Architecture by Charles Zhang. And then Vernacular Architecture Movement, led by Paul Oliver. Cradle to Cradle by MacDonald and Baumgart. Architect and chemist produced a book called Cradle to Cradle. So don't let cradle to grave. Bioclimatic Skyscraper by Ken Yang in Malaysia. Then Sustainable Development Goals as a new norm for us. Then come the pandemic. What can we do with pandemic and in modern architecture? Everybody go back to home, working from home. And then we have this hybrid seminar formation also. And the threat of profession, architects as a profession, because of artificial intelligence. Modern architecture is undeniably continually damaging environment. So, these are the images of the books I mentioned, published. Sustainable Development Goals and Pandemic as the Obstacle of Modern Architecture. Possibly these are the question. How can we save the world? By going back to learn from the wisdom of local people, or searching from historical facts for new architecture for our habitat. These are the research drawings from the remote area. You can see the airflow freely into the buildings. Also the Baduy, energy efficient. If you visit the Baduy village, they don't have electricity. They walk without shoes. And then no mosquitoes bite you. They have the wisdom of planting certain trees to avoid the mosquitoes. In the United States, we have a kind of new education system championing by Rural Studio, which using the local material help the local community to build with their own hand by using the discarded material. So we can learn from them because they ask the community what they really need and how can they build by themselves. So the student get the first-hand experience in the site rather than in the studio of the university setting. Should we ask AI or robot to help us find answers? architects is also Homo sapiens that hence should be wisely do their jobs. Collaborative acts were the species' strength for survival. Let's find the solution wisely. So thank you very much for your patience. These are my presentation. You can control your slide.
Thank you very much, Prof. Gunawan, for the insightful presentation about what the lesson learned. So we usually learn from best practices, good practices, but sometimes we forget how to learn from the mistakes, and eventually we made the similar mistake in the future. Thank you very much for this Hannah's presentation, Prof. Gun. Two things that I highlight is the form follow function of the modern architecture undermines several things that are one of which related to the climate, and also it has a less feeling and informality, and also lack of the locality itself. While our climate is very related to the local climate. But I apologize for Prof. Gun. I was too excited to listen to your presentation and forgot to mention your bio, but it's still my job to give briefly about your bio. So, ladies and gentlemen, Professor Gunawan Cahyono is an emeritus professor from the Department of Architecture at Universitas Indonesia. He is a member of Advisory Board of Traditional Dwellings and Settlements Review. Currently, he is running Yayasan Professor Gunawan Cahyono, a foundation to promote the study of vernacular architecture. And the next presentation is still related to the vernacular architecture. When we talk about vernacular, it's not just about the visual, but it's about the locality. So now we will dig more on the locality in terms of the climate. We will learn from the I think this is from the extensive research from Professor Kubota-san from Hiroshima University. The floor is yours, Prof.
Thank you so much. Let me stand up. Ladies and gentlemen, selamat siang and very good morning, ladies and gentlemen. So I'm Tetsu Kubota from Hiroshima University. So first of all, it's a great honor for me to deliver the presentation in this kind of very wonderful occasion. So thank you very much for inviting me. Can you open my slides? Thank you. Okay, so today I'd like to discuss not the ongoing project, but the slightly previous, the old the research results about the vernacular architecture from the viewpoint of from the scientific viewpoint. Okay. First, I'd like to define the term vernacular. So, as you may know, the term vernacular is originated from the Latin word, which is vernaculus. So that means native. So therefore, literally, vernacular architecture means native architecture. Right? As you may know, that the vernacular architecture is constructed by the ordinary people, as you may know, including often occupants itself, and then the modified and also improved by trial and error from the generation to generation. So that is vernacular architecture. So yes, as you know, that each of the climates and each of the culture has its own unique feature of vernacular architecture. As you can see here, all across the world, we can see the very interesting example of for instance, this one is the whitewashed, nice, building. This can be seen in the Mediterranean, the region, Greece, for instance. This is because they want to reflect the strong solar radiation. Right? And Mali, for instance, they experience the hot and dry climate. So therefore, in order to protect from the very, the extreme hot weather, so they construct it by using the mud and sand, as you can see on the upper part of the the slide. And then Philippines, for instance, our region, Southeast Asia, of course, the hot and humid climate. So therefore, needless to say, shading and ventilation are most important. So therefore, sometimes we construct this kind of nice thatched house on the water bodies, as you can see here. So as such, so we can see interesting, example from the, the most parts of the world. So that is vernacular architecture. So nowadays, as you may know, this kind of vernacular architecture tend to be re-evaluated by the designers and also even researchers, especially recent years, as you can see here. So we can see many relevant books, so published recent years, as you can see here, like 2000 and even today, right? So why now, this kind of vernacular architecture is re-evaluated, right? So I'd like to point out at least 3 reasons for that, right? Number one is, needless to say, energy aspect, right? Air conditioning, for instance, was developed in US around 1930s or 40s, if I'm not mistaken. Now, the air conditioning is now, widely penetrated in Indonesia, for instance, from 1980s, 90s, and 2000, and so on and so forth, right? So it is relatively new technology, needless to say, right? But of course, this vernacular architecture existed much beforehand, needless to say, and by somehow, so people, that cope with harsh climate, hot and humid climate, without using air conditioning, right? So this is, needless to say, very passive and energy-saving techniques that are very much nicely embedded inside of the vernacular architecture. This is one of the things that we can learn from the vernacular architecture, and then better to apply this to the modern houses. That's number one. Number two is also material sustainability. So this aspect is also important, right? Nowadays, we tend to use energy not only during the operational phase, but also during the construction. When we construct a building, we consume so much energy to produce and construct a building, right? This is so-called embodied energy. So in this aspect, also we can learn a lot from the vernacular architecture, because vernacular architecture normally make use of the domestic materials as much as possible. And then, so that can be seen nearby the building. So that is very, in a way, energy efficient, resource efficient, right? That's number two. Number three is the cultural aspect. That's also very important. As the previous professor mentioned, modern architecture tend to be westernized and also homogeneous in a way, right? We tend to lose the locality and diverse, culture, right? But this diverse culture and also very nice, rich locality is still maintained in the vernacular architecture, right? This is also what we can learn from the vernacular architecture. So today I'd like to introduce 3 fine examples from, Malaysia and also Indonesia. I used to be in Malaysia for 6 years until 2009. And after that, I have been concentrating on Indonesia. So therefore, today I'd like to pick up 3 examples from the the country, Malaysia and Indonesia. From Malaysia, Malay house, that's number 1 example. And then, elevated floor and thatched, nice timber structure, as you may know. That's example number 1. Number 2 is a Chinese shop house located in Malacca. That's example number 2. And number 3 is, Bandung, the Dutch colonial building located in Bandung. So, so these 3 examples, I'd like to talk about. So the first example is, as I mentioned, Malay house. Malay house is, as you may know, can be seen almost many parts of Southeast Asia. And then the main feature is, as you know, that first of all, timber, the nice, structure, and elevated floor to, protect from the flood, and also stimulate the ventilation. And then the inside is the less partition, again, to stimulate the ventilation, and also large attic space to prevent the heat from entering. and etc. So these are the main feature of yes, so-called Malay house. As I mentioned, I used to be in Johor Bahru, Malaysia, and then these Malay houses still exist in the rural areas of Johor Bahru, Malaysia. And then we, pick up 2 examples, and then we conducted some, the thermal measurement, the field measurement inside of these existing Malay houses. Let's say house 1 and house 2. Yes, this is one of them. So as you can see, still they still maintain the original nice, beautiful feature of Malay house. But the one, important change is, this is unfortunate change, is the roof material. So needless to say, the original roof material used to be thatch in the plants. But now it is, in order to, reduce the maintenance, they tend to change the, such a thatch roof to the, modern zinc roof. So this zinc roof is, of course, it's easy to maintain, but the thermally it's not so good. The thermal resistance is almost 0, so therefore the heat is easily penetrate into the indoor spaces. But except for the roof material, yes, as I mentioned repeatedly, the existing Malay house still maintain the nice original feature of the traditional vernacular Malay house. Like the occupied space is nicely surrounded by the semi-open spaces. They have this kind of nice veranda and deep eave, and also the house is nicely surrounded by the tall trees. These tall surrounding trees nicely give the shade to the building and also cool the air before entering the house. So this is inside. So as I mentioned, they don't put so many partitions purposely in order to stimulate the indoor ventilation. And also they designed the permanent opening on the upper part of the door, as you can see here. This is also for the ventilation. And normally, originally, yes, they don't have ceiling. But as I mentioned, now they use the zinc roof. So this is very hot. So therefore, they tend to put the ceiling instead of that. So once they put the ceiling, yes, they can protect from the heat, but this may reduce somehow the natural ventilation. Yes, I'd like to emphasize this. Yes, this is the greening. So the surrounding tree is really beautiful, and then this play a very important role to cool the surrounding environment, so-called microclimate. So I will emphasize this again later. So this is the indoor and outdoor temperature measured by yourself, and then as you can see here, the black indicates the outdoor temperature, and then the orange indicates the indoor temperature measured in the living room of the Malay house, as you can see here. Right. And then basically, Malay house is timber structure, wooden structure. So this doesn't have a huge thermal capacity, as you know. So therefore, yes, as you can see here, indoor temperature nicely follows the outdoor temperature because of this, the less thermal capacity, right? So this is normal and natural, right? So then, as you can see here, the daytime, yes, the temperature increase, according to the outdoor temperature until 30 to 31, and then the nighttime reduce and drops until the outdoor level, as you can see here. Slightly, higher than the outdoor. This is because of the occupancy, and also they close windows during the nighttime. So therefore, indoor temperature nighttime slightly higher than that of the outdoor. But normally, yes, that nicely follow the outdoor temperature, right? And then here, yes, as you can see here, the indoor temperature of the Malay house still maintain relatively lower level. That is 31 or 30 degrees Celsius, right? As you can see here. The important point is, in a way, it's not the indoor temperature, but the outdoor temperature, interestingly. So please just imagine, so this is Johor Bahru, right? The tropical, needless to say, climate, right? But still, as you can see here, the background outdoor temperature still maintain relatively lower temperature, which is 31 or 2 degrees Celsius. If you take a look at the urban temperature, as someone mentioned, right? Oh, the urban temperature is much higher than that of this. Let's say 33 or 4 degrees Celsius. This means that here, the Murray house, surrounding background, outdoor temperature is 2 degrees Celsius, lower than that of the urban areas. Why, 2 degrees Celsius lower than that of the urban area? So this is because of, number one is that, yes, less urban heat island, needless to say. The Murray house is located in the rural area, so therefore, yes, less urban heat island. So therefore, yes, the temperature is lower than that of the urban, number one. Number two is yes, the vegetation. As I mentioned repeatedly, the Murray house is nicely surrounded by the tall trees. These tall trees nicely give the shade and also cool the air before entering the house. So this is also a very important point, right? Because of these 2 points, yes, the surrounding background, the outdoor temperature still maintain, yes, lower level, right? That's why, yes, the Murray house still enjoy the relatively lower indoor temperature accordingly, right? Okay, so this is, but humidity is a bit higher, but this is not the, out of our scope today. So let's move on to the next. This is summary of the environmental techniques used in the Murray house. So I have already mentioned repeatedly. So therefore, yes, the number one is, needless to say, the basically timber structure, fully utilize the natural ventilation, as I mentioned. And then the shading is very good, the make use of the, the deep eave and so on. The shading is good. And yes, and then as I mentioned very repeatedly, the most important is the surrounding trees, the cool the air before entering the house, right? Pre-cooling in a way. So, okay, the next one is the Chinese shop house. This is also a very interesting example. I just want to tell you the detail. As you may know that, yes, this kind of Chinese shop houses are still located in some of the, the unique towns in Malaysia and also all across, Southeast Asia. In the case of Malaysia, especially Georgetown, Penang, and also, yes, the Malacca. So they have so many, yes, the shop houses, as you may know. The most important feature of the shop house is literally the ground floor is used for the commercial purpose, and then the first floor, the second floor is used for the residence. So therefore we call it shop house. And then the interesting feature is the very deep plan. The frontage can be the 4 or 5 meter only, right? But the very deep plan sometimes 20 or 30 meter depth, right? So therefore, the very inside is dark, right? Because of this kind of deep plan. So therefore, and also the very poor ventilation, right? Then the Chinese people, very wise actually, they designed the nice internal courtyards, inside of the this kind of deep plan, the building, in order to secure the natural daylighting and also natural ventilation. So therefore, the most important feature of the Chinese shop house is the internal courtyards. Okay, so the Malacca, I'd like to introduce Malacca. Malacca was occupied by the several countries. Unfortunately, as you may know, the Portuguese and Dutch, and also UK, as well as in a way Japan also. Right? So therefore, we can see interestingly the different influence from the different countries. So that is Malacca. So still, yes, this is the current situation. The main street, the both sides of the main street, there are so many, yes, the shop houses still exist and well conserved. So that is Malacca. Right? If you take a look at the detail of the facade design of the shop house, you can see that some difference of the design influenced by the different country. Some of them are influenced by Portuguese style, and then Dutch and UK and etc. Right? Very interesting. That's the shop house. But let's go to the science, right? Today, yes, just as before, so we fortunately we managed to conduct the field measurement yes, in the 2 adjacent shop houses, and thanks to the NUS. And then we measured, just as before, the thermal conditions inside and outside of the shop houses in the 2 houses. So I'd like to share with you the interesting results. Inside is this. So as I mentioned, the frontage is only 4 meter or 5 meter. But as you can see, the very deep plan, 20 meter or 30 depth. As you can see, this is the typical layout of the Chinese shop house. So then, as you can see here, that they have several courtyards in order to secure the daylighting and ventilation. Here, for instance, the first one is a very narrow and deep courtyard, courtyard 1, and then next one is a slightly wide courtyard, and then in the end of the the site they have quite large, shallow courtyard. Right. So this is what I said. Very interesting feature of the courtyard, the Chinese shop house. Right. And then the Chinese shop house, adapt so many passive cooling techniques at the same time. So for instance, each of them are quite tiny, but they adapt many kinds of passive cooling techniques at the same time as a system. Right? That's an interesting point. For instance, the high ceiling. So this is 4 or 5 meter, as you can see, very tiny thing, but it quite makes sense. Right? And also for each partition, they have, again, just like Japanese traditional house, they also have permanent openings, just like Japanese ramma, in a way, the lattice window, and to secure the permanent ventilation, as you can see here. Right? And then this is the courtyard, as I mentioned. Sometimes they also place the well in order to stimulate the evaporative cooling, interestingly. And sometimes they put some plants also to give the shade. Right? And then the roof tile is also interesting. So they use the terracotta as a roof tile, and then this can retain the rainwater, again to stimulate the evaporative cooling. That's everything makes sense in a way. Right? So that is, yes, Chinese shop house. This is really amazing result. So I was very surprised to see this result for the first time, actually, in a long time ago, but together with my students. So yes, this is again just the temperature measured inside of the Chinese shop house, together with the corresponding outdoor temperature, as you can see here. The black indicates the outdoor temperature, and the blue and orange indicates the temperature measured inside of the main room, so-called living hall in the Chinese shop house. Right? Oh, it's amazing, right? So daytime temperature is, as you can see here, 5 or 6 degrees Celsius lower than that of the outdoor temperature. So this is, amazing, right? So that's number 1. Number 2, in a way, this is why so low. So this is because of the so-called thermal mass effect. As I probably mentioned, Chinese shop house is made of brick and concrete, right? Basically, and this has the huge thermal capacity, right? And therefore, this can maintain the relatively lower temperature during the daytime. So this is the reason for this, right? But the more amazing point is that, yes, nighttime, nighttime indoor temperature is almost same as that of the outdoor level. So this is really amazing, right? Normally, in such a, high thermal mass, building like, brick house, right? Daytime temperature can be lower than the outdoors, but the nighttime temperature should be higher than the outdoor level. So that is normal, actually. But this is therefore quite amazing, right? Why this kind of amazingly, the lower temperature can happen, right? So this is because of the courtyard. Please take a look at this. This is the vertical distribution of the air temperature measured at the several points inside of the courtyard, right? Inside of the Chinese shop house. Upper one indicates the daytime condition, and lower figure indicates the nighttime temperature distribution. Right? It's very interesting actually. So let's take a look at the reason why, first, is that why daytime temperature is 5 degrees Celsius lower than the outdoor, right? Yes, as you can see here, inside of the courtyard, right, we can see very clear temperature gradient, right? Clear temperature gradient. Needless to say, the temperature increases with height, right? And then here, the Malacca, the outdoor temperature is about 33 degrees Celsius, as you can see here. Upper part of the courtyard is about, it's almost same as that of the outdoor level, 32, but interestingly, the lower part of the, Chinese shop house, the very low indoor temperature is now maintained, right, which is about 28 or 9 degrees Celsius. So, right. And then this is the reason. So this means that now inside of the Chinese shop house, thermal stratification is now happening, right? This means that the upper part is the warm air, right? And then the cool and dense and heavier, the air, stays on the bottom part of the building, right? And then thermally, now well stratified, right? So that is the reason why, the occupant area, the bottom part of the building maintain the quite relatively, lower temperature during the daytime, right? So that's interesting point number one. Second is the nighttime. Nighttime, as you can see here, unlike daytime, there's no temperature gradient, straight line. Straight line means, this means that yes, a thermal exchange, the air exchange between indoor and outdoor happening during the nighttime, right? So that's why there's a straight line, number one, right? Number two is, this is a really interesting phenomenon actually. The important point was, we also measure the surface temperature of the roof, right? Of this, V-shaped roof, right? And then we found that the surface temperature of the roof was approximately 1 degree Celsius lower than the ambient temperature during the night time. This cooled, surface of the, roof created the, very tiny, thin layer of the cooled air above the roof, right? And then this cooled air is dense and heavier, and then fall into the courtyard, right? And then this, the lower the temperature inside of the, the Chinese shop house, right? That was very interesting phenomenon, right? So this is a summary, right? Daytime, as I mentioned, that yes, thermal stratification happened, right? The warm air goes up, but the cool and dense and heavier air stayed in the bottom part of the building, right? That is that is the reason why, right, daytime temperature still maintain lower level, number one. Number two, nighttime is very interesting because of the V-shape, the roof, right? Interestingly, the thin layer of the cool air is created, right? And then this cooled air, fall into the courtyard. And then, yes, the lower the temperature inside of the building, right? That's a night, yes, this, huh? Okay, the last, yes, is the Dutch colonial building in Indonesia. The Dutch also building also, during the very long, occupation period, they also adapted to the local climate, as you may know, right? So let's take a look at one interesting example from Bandung. So this was conducted by, Dr. Ariel, and then together with me during his PhD study. So yes, we selected one, the single-story school in Bandung, and this is also the high, the thermal mass building, right? As you can see here, the concrete and brick and lime cement, and then the wall thickness is quite thick, 28 centimeter and so on and so forth, and then ceiling height is quite high, 8 or 6 meters, as you can see here. And as usual, we also measure the thermal conditions inside and outside of the building at the time. Yes. Thanks to Ariel-san. And this is the result. Yes, again, interestingly, the indoor temperature maintained lower level, as you can see here, compared with the outdoor temperature, as you can see here, right? So this is because of two things in this case. One is the main room is surrounded by the nice semi-open veranda spaces on the eastern side and also the western side, right? These semi-open spaces play a role as a so-called thermal buffer, right? And this nicely gives the shade again to the main room, right? That's the reason number one. Reason number two is, yes, interestingly, this kind of high ceiling is also play an important role. So as you can see here, when we take a look at the vertical distribution of the temperature inside of this, the high ceiling, the colonial building, yes, there's a clear temperature gradient, right, as you can see here. And then although the upper part, the temperature is almost same as that of the outdoor level, but the lower part of the building, yes, still maintain, the 4 or 5 degrees Celsius lower than that of the outdoors, still maintain very comfortable temperature for the occupied spaces, right? So this high ceiling is also very important point, yes, to maintain the, thermal comfort inside of the vernacular, colonial building. Okay, so this is the summary of my presentation. So as we saw in the many good examples, so vernacular architecture embed various passive design techniques to achieve thermal comfort, right, without using air conditioning. In particular, semi-open spaces, as I mentioned, and surrounding plants, trees play an important role as a thermal buffer and also the shading device. Right? Material sustainability is also important. We should not ignore. Right? Also ensure using domestic material. And I think it is quite worthwhile to try to apply this kind of vernacular techniques to the modern architecture, but still, in a way, it's challenging because now the culture is also evolved, right? Already evolved, and also we are now living in the urban setting, right? Which is different from the indigenous setting. So this kind of things is also important for the future consideration. Right? Okay, so thank you very much. That's all from my, yes.
Thank you very much, Prof. Kubota-san, for the presentation. So sharing your research in 3 different areas, and you show us that three types of the buildings and how those buildings apply the vernacular architecture and how its performance in provide comfortable temperature, indoor temperature. You mentioned that the importance, like for example, the open spaces as a buffer and provide shading for the building, and also to use the local materials as well. So I also apologize to forget mentioning your bio in the beginning. So let me sorry. Your bio. Professor Dr. Tetsu Kubota is a professor in Graduate School of Advanced Science and Engineering, Hiroshima University, Japan. His research area is building science for international cooperation together with Dr. Al-Fatah. He is leading the SATRAT project and international collaboration between PUPR and Hiroshima University, aimed at developing models for low-carbon, affordable apartment buildings in the hot, humid tropics of Indonesia. The one that we saw in Tegal, the Rusun in Tegal. For the next presentation, so we have discussed about the building scale and site scale. Now, because climate change is So now we will discuss about the larger scale, the urban context. And as a climate change is an everybody business, so we need to collaborate in response to this climate change and prevent the adverse impact to the whole populations. And our next presenter is Dr. Johannes Anhoorn, or Pak Jo. And Dr. Johannes Anhoorn is advisor and GIZ. In 2022, he is an advisor on renewable energy and energy efficiency in key industrial sectors and sub-national government units to support Indonesia's energy transition. In 2023, he is the consortium coordinator and team leader in sustainable energy transition in Indonesia, or SETI. The floor is yours, Pak Jo.
Ya, terima kasih Ibu, Bapak, Ibu sekalian. Mohon maaf ya, yang presentasi akhir sebelum makan siang paling susah ya. Semua sudah capek, sudah banyak informasi yang baru. Dan juga saya akan pindah ke bahasa Inggris lagi. Karena saya juga capek dengar bahasa Indonesia yang masih saya harus belajar sedikit lebih. Maaf ya. So it's a big stretch actually from my previous speakers to the topic that I'm supposed to talk about. After hearing about the technical background of the newly launched map for passive cooling potential in Indonesia and how to integrate a lot of data sets into that from from Badan Standarisasi ya, sama PUPR, together with PUPR, to the vernacular building types. If you bring up my slides, I have a lot of repetition from my previous speakers, so I can assure you we can go faster and move to the main topic of the conversation of this presentation. Collaborating on adaptation, mitigation, and climate change in urban areas, looking at the building environment in Indonesia is quite crucial. I see a very successful collaboration that has just been happened and launching results of this collaboration today between JICA, PUPR, and BMWK. There are many more collaborations and many more actors that need to come together to shape our sustainable future. And I think among GIZ, there are many other international organizations, donors, collaborators, partners, ready to support the Indonesian transition towards a greener, sustainable future as well. We know this already, we have seen it, there's a land surface temperature gradient between urban and rural areas. There is even now the new passive cooling potential map, which will hopefully really help young architects, old architects, young architects, to go back to and learn about the potential that they have in passive cooling. But yes, we have also mentioned that previously active cooling still plays a crucial role as well. So we use a lot of energy to actually fight against those urban heat islands that are based on the dense infrastructure, the diminishing green spaces that we have, the destruction of sometimes the airflow corridors of larger or mid-sized cities as well, the anthropogenic heat that we're producing as well through our day-to-day activities, increase of albedo effects, etc. So we have this urban heat islands, but we've heard already about some of the potential solutions here. All of this will be worsened by climate change. This is also not new to you. Higher indoor-outdoor temperatures, direct impacts like health-related issues, respiratory problems, issues, blood sugar, high intake of insulin, diabetes type 1, loss of performance, work and study, etc. There's indirect impacts as well, so we do have more cooling demand. So the usual reaction will for people not to start like starting passive cooling. They will start having another AC. They will have maybe increase or decrease the temperature of their air conditioning. This will be the first reaction, because on the long term, maybe you might consider moving out of the city. You might consider changing the space that you live. But this depends on your resources, on your capabilities, right? Not everybody can afford to choose the best, sustainable, nice living place that we have. And those people we also have to take care of. So increased mortality, I already mentioned that in Europe we had quite severe heat waves over the last couple of years. In 2003, I think it was like a ringing the bell event with an estimated 70,000 people dying. In the UK as well. Southeast Asia is facing this on a regular basis. I think last year, I remember onset of musim hujan was delayed due to El Niño effects also until late November. I think we planned for the birthday of my first son in end of November, and that was the first day it started to rain. We wanted to be outside, but this was exactly the day when it started to rain. So mixed feelings back then for me, but I remember that very well. This year seems to be more regular. Heart strokes, etc., also increasing in Asia, Southeast Asia as well. So why do we care about the building emissions, right? Construction, operation of buildings is about 40% of the energy-related CO2 equivalent emissions that comes from the building construction. There's a huge final energy demand from the building compared to 2015 numbers. It's approximately 50%. Energy intensity per square meter of buildings need to improve on average by 30%. That's what's compared globally. And globally, energy consumed by air conditioner already equals 2,000 terawatt hours every year, which is, fun fact, similar to the final energy consumption of the whole Indonesia in 2023. So the world is consuming as much as Indonesia does on cooling only, or air conditioning. Just to remind us as well, there's another entity in Indonesia that's taking care of those issues as well under the enhanced NDCs, right? KLHK reporting on that. So where do we account for all the GHG emissions that are happening? It's under the energy section. We have energy efficiency as one of the options to mitigate those effects. But we also have the potential for increasing EBT, energi baru terbarukan, so new renewable energies as well as a high contributor to that potential. Divided by commercial and non-commercial building types, we can see that there's a huge potential to increase on that. So, but what is really happening at the moment is household and commercial actually increase their consumption. They're still making like 50%, but the overall total consumption is also still going up, mainly related to the cooling necessities of the new middle class as well. So how to bring it down? First, reducing the energy performance index of a building, so reducing the actual per square meter energy consumed. And to increase RE generation inside the building perimeter, which means you can actually use renewable sources to reduce your GHG emission footprint, and also have like direct cooling effects through that. We've heard about, I found that very interesting actually, from the Malay building, using not the original building material anymore, but have a thin roof, which has a very, very bad energy penetration ratio. But adding like solar PV on top actually reduces that impact to the inside of the building as well. So there's a double effect. I would love to see that numbers at some point. Maybe Professor can do some research on that to see what a tin tilted roof actually has an effect if you put solar on top. So I assume most of you are aware of the energy use intensity factor. It's basically the kilowatt hours used per square meter. And if you look at the right side, you see that like more than 60% for the different building types are actually based on the cooling technology used. For sure, different building uses have a different profile. We see that malls in generally are a bit more consuming. They spend a lot of money on the cooling, while it looks like Indonesian hospitals are doing quite well in terms of having a lower energy use intensity. Hotels very much interested in reducing the impact, because it's high cost for them, right? It's operational cost, and this is where they see like a high benefit to reduce. Talking from the EE to the RE, there's also a huge potential on the residential area for introducing RE technologies. Two scenarios are depicted here. This is the actual installed capacity compared to the estimated potential. You see there's still a lot to do in solar, which has a very close link to a rooftop. A study showing here that with 100% solar rooftop coverage, there's an anticipated gigawatt peak of 1,312,000 gigawatt peak to potentially be installed. Currently limited by the offtake regulations from PLN. So the actual regulation would allow for 27%, which still means there's a 354 gigawatt power peak potential that could be utilized in the building sector, only in the residential area here. So very high unutilized technical potential for renewable energy utilization in the building sector as well. You saw that I'm from GIZ, German International Development Corporation. So looking at Germany, what happened there over the last 30, 40 years is that we have managed to increase our RE share in the total energy consumption from around 6% to 56%. We had last year several days with positive energy production from renewables, which as an interconnected grid in Europe was still a challenge, even though we are well connected to our neighboring countries. But there was a huge demand of shifting that electricity to our neighbors, actually paying them to take it off from Germany. And this is mainly because we have a lot of private-driven solar rooftop investment happening over the last couple of years, incentivized through the government for having power purchase agreements with the individuals, basically to be the sole off-taker and paying a bonus for the solar-powered solar generation. But this actually helped really to drive this development as well. So let's do some little myth busting. This whole topic is still complex. It's like way too complex for us to deal with. We have heard about the wisdom of the humankind that needs to be utilized here. We're all alone, right? I cannot stop this. The climate change is just too big. Government is doing nothing. I don't know any cheap solutions that I could use here. And the technology that I would need here in Indonesia is basically not available to me. Let's try to look at a few of those myths and bust them. So I'm alone fighting this. It's too complex. I would definitely challenge that. There's this pentahelix model of collaboration, and I think we saw JICA today here. We see the collaboration PUPR, BMBK. Sorry, colleagues. I'm always confusing because our German ministry is BMWK as well. So I'm confusing with BMBK, yeah? Huh? BMKG. Maaf ya, I'm very sorry. So there's like universities we have in the room here. There's the private sector who is not present very much at the moment as far as I can see. And then non-profit, international organization, and enthusiast citizens that need to come together for an open dialogue, supporting their roles, and basically moving all together as a group. Government is doing nothing is also a myth, but it faces the risk of being over-regulative. I think we hear that a lot. from people that there's always a risk to have like over-regulation, but I just depicted a few of those laws and regulations that are already in place from different ministries. Overarching target to commitment for climate change, principles and standards for green building, Permen PP 21, and then there's also PP 33 from ESDM on konservasi energi, so energy conservation for the building types, also the regulation on solar rooftop. So actually we have the rules, regulations, and everything in place. There's green certification, there's green buildings, there's even awards for that, so you get like prestigious visibility if you move towards letting your building certified, and you for sure have the benefit of a green building. It's very expensive to change something, and others need to bring cheap technology first before I will do anything, right? This is also sometimes what we hear when we engage with stakeholders, private sector, but also house owners. Yes and no, right? There's innovation, there's solar-powered cooling units, there's district cooling opportunities, there's simple things like vernacular building using the passive cooling technologies as well, right? Going down to planting trees, this is where a lot of the environmental movement has started with planting trees. It's still something that we need to do, because if there's no source of cool air, passive cooling will also be very tricky for a well established and built building. There's RE generation potential. These are horizontal integrated photovoltaic systems that also help to reduce the albedo effects. This can happen and is happening due to generation cost that has been dropped. We also have now the new regulation for TKDN, which has been revised, which makes the installation of solar much more feasible. In Indonesia, there is a scam system for labeled appliances, which will be increasing from the ones that are already existing to this was the battery, to more advanced and more efficient ones as well. Lanjut, bisa? Karena ini sudah. Yes. Business operations, we heard cradle to cradle, but also in terms of waste to energy, waste usage from the city, feeding back energy to the city for cooling technologies, for example, can be used. Lanjut. Low carbon building transition in Indonesia. So there's some important progress. There's the regulatory framework. There are business players starting to provide such services, cooling as a service, energy audits, energy managers. They are standing by, they're waiting to get their job offers. Initiatives and funds are also available through various international and non-international or philanthropic organizations. And also NGOs are doing their job. Lanjut. Progress means also there's still some challenges, right? There's still a bit of a lack of dedicated financial instruments, incentive structures that really help to move from standardized building technologies to green building technologies, and to take care of the additional costs that might imply. Focus mostly on reducing the emissions from the building operations. The embodied carbon is a remaining challenge, looking at the need for increasing also housing capacity in general. And I'm quite happy to say that here in front of this audience, actually, I think architects still have not put enough attention on this topic and are not yet equipped well enough with knowledge in their curriculum in learning about passive technologies, active technologies, and how to mitigate the high costs in cooling. And I think among us international donors also, I think GIZ is ready to jump into that as well and support developing it and making sure that the new generation of architects are actually focusing and aware of those situations and know the tools at their hand, without losing the essence of architecture, actually, which I think was very well explained also in the first presentation on the architectural issues. Maintaining the Southeast Asian, Indonesian styles that are existing across the peninsula, instead of building concrete buildings all over the place only. Please, next. So what we know so far, building sector is responsible for a significant amount of greenhouse gas emissions. We are running 2 projects currently that are very well linked to this. One is called Sustainable Energy Transition in Indonesia. The other is the Program for Energy Efficiency in Buildings, PEEP, and its PEEP Cool part. Next, please. So looking at sectoral investment frameworks, developing and supporting public policies, moving policies into action, support capacity building through trainings and design studies, including working with institutions like universities, for example, and broadening the knowledge base of national and international available technologies. Next, please. The SETI project has also tries to incorporate the financial sector as well, because we see that on the financial institutions, they're sometimes hesitant to move into this area due to not understanding the technological risks or the technology behind it. So financiers need to understand technology, and technology providers and builders and architects need to know how to convince banks and those who give them their loans why certain extra costs, for example, are really worth on the long run to reduce operational costs, for example. This is something that needs some sort of mind shift also in the way people think about sustainability when doing their day-to-day business from the financial side, but also project developers and technicians. So rephrasing what a professor said earlier, that the engineers will be able to accommodate those change. There's also the bankers. I don't know if they are engineers or not, but they're at least looking really for the numbers and the details. So they need to be convinced as well. So I think it's all together. It's a task for the whole society. Next, please. So yeah. So a multitude of actors are actually already supporting this necessary energy transition and decarbonizing journey of the building stock here in Indonesia and worldwide. And if you just click 2 more times, then I think everything will pop up. This is the consortium currently working on the SETI project led by or coordinated by GIZ. We are very closely collaborating with our main political partner from EPTKE, MEMR. But there is also, and if you click another time, there are so many other donors that are working in this field with a similar agenda. And I think sometimes I hear, you're all doing the same. You internationals, you Germans, you come again and you do this, the exact same like all the others have done. We have done this with JICA already. We have done this with USAID or vice versa. I think it's our shared task to coordinate that well and to align it with the programs that are existing. And I'm really asking the Indonesian representatives and the Indonesian government also to continue this coordination on those efforts to make sure that we're all moving in the same direction. I think we're all kind of under the framework of the Sustainable Development Goals, and this is our shared responsibility. So I think there's not yet too much. There's maybe a lot. It requires a lot of coordination, but I think we're all on a good way to do this together with so many different partners. Continue. So I took from the month, this urban month now, also that youth should actually at the center. And I'm looking around and I share that there's not so much youth, at least in this room. Maybe they're all on Zoom, so I'm saying hello. I still consider myself being part of the youth, which is probably wrong when I ask young people. But what can they do? What are they doing? They don't build the houses. They don't bring the money, but they will be the next generation who do that. They are the ones who decide where to live. They maybe want to see how the Jakarta is developing or other cities are developing. They bring a high technology readiness, so we're assuming that they can help the acceleration through technology and applying technologies very fast. They are, to a certain extent, self-consciousness or more conscious about their environment, and can use multiplication effects. So let's focus on them as well. Let's train them with the knowledge that we have that's in this room. Let them show what has been done with the passive cooling potential to avoid maybe that their first salary goes into buying a new air conditioner for home. Thank you very much. Planted? So yeah, looking back at the myths, I think, yes, we can. There's a multitude of actors, and there's a regulatory framework in place. We are not alone. There's so many people supporting this. And I think also technology-wise, there are plenty of options that are already available with short return of investment as well. So it's time for us, it's time for the youth to shape our future as well, to make sure that our future cities are livable and nice places to stay in. Thank you.
Thank you very much, Pak Jo, for overarching presentation. You start with the awareness. As our Secretary General mentioned, that we are not in global warming anymore. We're in global boiling, and you can imagine the threat, this high temperature to our health. And then you also broke some myth on the low carbon buildings, to implement low carbon building, including that we're not alone. There are a lot of people doing it, because perhaps we're just not. We haven't. This forum is kind of, we discuss from different actors who's in this attempt, and also regulatory. Some people think the government did nothing, but actually a lot government has done, but it really needs multiple actors to implement the regulations, and also about the cost. And you also share about what German government has done. So we mainly talk about to reduce the energy usage, but you also mentioned that to transform the energy source to renewable energy, and also about the pentahelic collaboration and some challenge to implement the low carbon building, and that also needs a collaboration to implement it. So I think we have about 20 minutes for a question and answer from the audience, participant who are in this room with us, and also participant who joining online. Perhaps I can open 3 from the audience. Is there any questions from the audience? Yes, one. We can start with the first questions. If someone can pass the microphones. All the way. Please mention your name, your affiliation, and the questions briefly. Thank you.
Okay, my name is Jonathan. Okay, first of all, I want to express my gratitude to the speakers. It was such a great presentation. Okay, one of the urban issue regarding to the temperature is the urban heat island phenomena. Mr. Kubota mentioned that this problem can be tackled by the provision of vegetation. Well, talking about the collaboration output, which is the Tegal Apartment, my question is how the SATREP implement the vegetation in order to reduce the local temperature in Tegal Apartment.
Perhaps do we have the second questions?
Yeah, thank you very much. My name is Aril, so from PUPR. Yeah. First of all, thank you very much. So I'd like to ask first for Pak Ju, yeah, about the collaboration. Yeah, that's so interesting. But unfortunately, I didn't see PUPR there in your strategic plan, perhaps. Yeah. In the second is, I'm very interested in the embedded carbon you mentioned about in the future plan about the energy transition, if I'm not mistaken, in the building sector. Yeah. So this is my first question. How do you, what are you going to do with that kind of the embedded carbon in the future in your plan of the collaboration, for example? And the second is, after looking at this launching this morning about the potential passive cooling for map and also for the standard weather data, I think there might be something that we can do more by collaborating all the resources here, right? So can you, for example, GIZ or probably other organization here, in your opinion, what can we do with this kind of this map and weather data in order to improving our quality of life and also the energy efficiency? And I'd like to, the second is for Prof. Gunawan Cahyono and also Prof. Tetsuko Puta. Yeah, probably a simple question actually. So yeah, if we take a look to the vernacular architecture, most of them are located in the urban area, but current challenges are in the urban area and context. We found that probably some of the passive techniques, cooling techniques applied in the traditional buildings was related to the material, for example, and the building design and so on and so forth. So how we contextualize these findings of the vernacular architecture into the modern context in the urban area? As you know, probably we have a very limited area in urban area, limited site in urban area, different materials, for example. As you know, probably that timber material still expensive in Indonesia, for example. And also we have like KDB, KLB, with probably might limited the use of the overhang in for the building in order to shade the building. I think that those are my questions. Thank you very much.
Thank you. My name is Rezeki Prangin Angin from Cipta Karya. I'm very interested with the last speaker. Yeah. I think maybe this is not question. Just I want to say that the key success to combat this climate change is collaboration. Because if we talk about climate change, there is no border. There is no border for climate change. Everybody will get an impact from this. There is no races for this climate change. The rich people, the poor people, black people, white people will get the impact from this climate change. So I think the collaboration is the key success for the for how to we combat the climate change. So maybe Mr. Joe, I support that your initiation to make a big collaboration, not only in Indonesia, but all over the world, yeah? Because we have only one space, no other space. And we all live here, and this world is not only for the youngest, but only for us also. I think that's I want to say. Thank you.
All right. Thank you very much for the audience who asked the questions. Perhaps for the first questions, can I confirm your name and affiliations? And the question is about the Rusunawa it's Rusun in Tegal. So how the vegetations help to create the microclimates in the building? Is that correct?
Yeah, that is correct. Because
Yeah.
I haven't seen the design of or the strategy for the vegetation or the green space
Okay.
in the apartment. And my name is Jonathan, and I'm affiliated with Cipta Karya in the Human Settlement Improvement Department.
Okay. Sorry. What your name? Sorry, I have.
Jonathan.
Jonathan from Cipta Karya. Okay. Thank you, Pak Jonathan. I believe this question is for Prof. Kubota. If you would like to answer it. Yeah. So how is the green open spaces surrounding the Rusun in Tegal help to create the comfort for the indoor temperatures in that building? More on microclimate, I guess.
Thank you very much for a nice question. Yes, as I mentioned in the explanation of the Mare house, yes, as I mentioned repeatedly, the surrounding trees play a very important role to cool the air before entering the house, as I mentioned. So I think that concept can be applied to the even modern houses. So currently the Tegaru experimental house doesn't have such a nice surrounding trees. But maybe in the future, so I think it's better to plant some trees around the building so that we can cool the air. So just like we saw in the Mare house. Did I answer the question?
Pak Jonathan, does it answer, or do you have any follow-up questions? Can you use the microphone?
Yeah. Is there any vertical vegetation that implemented in the building, Mr. Kubota?
You mean the local vegetation?
Vertical ventilation.
Ventilation.
Vertical vegetation.
Vertical vegetation.
Yes.
All right.
Oh, understand. Oh, for Tegaru experimental house. Yeah, thank you so much. Now, actually, in Hiroshima, Japan, so now we try to develop the new type of so-called green blind. So by making use of the green and as a, as a shading device. And then we try to put such a nice, the shading device using the green on the, the north and also the south, southern facade in the future. So I think that is supposed to be the, as you said, that the, vertical, green strategy. Thank you so much. That's very important.
You, Prof. Kubota, for the answers. And then the next questions is, I think we can combine the second questions the question from Pak Arif and from Pak Reski about the collaborations, and I believe this is addressed to Pak Jo, and also about the after this events, what kind of potential collaboration that you have in mind?
Yeah, thank you very much. I'm trying to answer that briefly. So currently we are looking at the operational carbon only. Second, we are looking at the industry decarbonization as well, which might include also, let's say, cement industries, for example, which are one of the building materials that has a very, very high carbon intensity. So reducing their carbon footprint actually contributes to the embodied carbon reduction also for the building sector. For PUPR, yes, we are very happy to continue supporting and continue collaborating, or even open more channels to collaborate. We are at the moment supporting some of the policies for Green Building Secretariat, as we are also studying IKE, which I think will be done together for the different buildings types in support of PP33 energy management aspects of BGH. In order to use and utilize the mapping and passive cooling potential actually that has been done now, we are working with the Directorate of Energy Conservation, and passive cooling is still one of the first things to consider and first things to take into consideration when retrofitting, planning new or older buildings. We're in the process of supporting several cities from individual pilot buildings towards the whole energy system of a citywide assessment, and passive cooling options and opportunities should always play a role there. I would say we are kind of technology open, which does not exclude passive technologies as well, right? Even though they are not like appliances, but shift of mindset and require some retrofitting or modifications of the building hull, but they're still part of the menu that you can use, and I think it's very valid to check for all the opportunities, not directly jump into, let's say, the most expensive innovative technologies first, right? And I see a lot of openness as well, because, and this is maybe answering the last question also, this energy transition and this climate change issue requires an inclusive approach. So all our measures, all our cooperation efforts should always think about the effects to different groups within society that have different resources available to them. And I think this is very crucial, not just thinking about the youth, not just thinking about the elderly, not just thinking about the poor, not just thinking about the rich, but thinking of how do we want to manage this transformation? Who should, with what power, participate in that, and carefully balance beneficiaries and maybe those who will be like the first movers who take a little bit bigger risks, maybe bigger burden as well, but to really carefully graft programs and continuously monitoring that during our implementation. So I'm pretty sure most of you know also safeguarding concepts, social safeguarding, environmental safeguarding concepts behind this. And I think the way I understand and see how Indonesian government is also collaborating and working is in a very dialogue format, which for sure you can claim it's not the fastest way to move, but it's a more inclusive way. I think this is very important to make sure that we take people with us. It's people driven, but if people start objecting those transformations and feel left behind, I think there's no way this can ever happen.
Thank you, Pak Jo. Before I go to Prof. Gunawan and Prof. Kubota on vernacular architecture in the urban context, I have a question to Pak Marjuki before, because it's related to the collaboration and how the climate, the weather data can be used by in development. So we see that the local government is an important actor to implement this. How do you see the challenge that that collaboration between perhaps BNPG that provide weather data and then local government, or let's say city government, who oversee the development and who provide permit to the buildings to implement this? Because we cannot just discuss at the higher level, but we also need to acknowledge challenge at the local level and how we can overcome the challenge.
Thank you. Climate is changing now. We have to believe it. And the impact of the climate change, I think, in the sectoral, in the local government, that's important. So I believe that what Pak Jo, I agree with Pak Jo that right now is the key success for the combating the climate change within the collaboration. In BMKG, currently focus on the providing the climate information for sectoral through the co-development. So we hiring much more stakeholder to develop the information, and that information can be used for the sectoral. So it is important not only for the central governments that usually for the climate change issue focus on the regulation or something like that, but we have to take action in the local government that basically climate change impact on that area. Thank you.
Thank you, Pak. And for the last question, this is also my question. That's why I started to the for the last. And I always have when reading about the vernacular architecture, it's easier to think about in the rural area where the social capital is still high, and we have time to really digest what's the local conditions, and then to think about the design, and then to really implement it carefully. And however, in urban context, the needs of the housing is very high, and then also everything needs to implement it at fast. And that's so how do we take lesson learned from this vernacular architectures, and then to Prof. Gunawan mentioned about the challenge that because the industrialization and then prefab materials, we want everything to build as fast as possible, especially in urban areas, and also the Pak Arif mentioned the challenge in urban areas, so the limited of land. So building a house with the microclimate surrounded by the vegetation is challenging, and also building houses with the overhang is quite challenging. So what is your insights? Perhaps what we can how we can implement this vernacular architecture in urban areas? Over to Prof. Ogun first.
Okay, thank you. This is a big question, because when you come to urban area or a city, urban is actually an adjective. We misunderstood it for quite a long time in Indonesia especially. You cannot bring your culture and ask people to obey about your culture. The villagers usually use the customary law rather than a set of rules from the city. So now the term vernacular is in question as well, because vernacular originated from a slave born there, and then finally become kind of by Paul Oliver simplified into the native. But now probably we don't have any slave in our society, right? Or nobody wants to say about you are still a slave. So it's quite a different condition. I suspect that possibly we will not encounter a kind of rural condition anymore in 5 years or 10 years time, because the urban lifestyle will go spread around the world, possibly, especially in Indonesia. You can see everybody is using the smartphone now in the rural area, but there are still villages What we need to do is to learn from the success story of the village rather than success story in the urban area. When we go into your question, how to incorporate the knowledge of the local wisdom into the setting, architects usually the sinners of all of the environmental damage, because we serve the rich actually, who hire architects should pay a fee. So most the architect we listen to those becomes the patron, let's say patron and clients relationship. So we never serve the poor, right? This is a kind of very cruel fact about architectural field. Because the poor cannot pay the fee, but we can improve the community life. In the urban setting, the poor area, usually we call it slums, right? And it's kind of what in Bahasa Indonesia is a kampung area. It's kind of associated with slums area, dirty, and it's subhuman lifestyle or so. Now, the government should set in, because the government is the sole protector for the marginalized people, right? In the urban area, you cannot find the vernacular persons, actually, nowadays. But you can still have this poor living condition, which needs architects' help. But who will pay that? Usually by the government project under the so-called capitalistic world. We are now all in, right? We can enjoy this kind of living because of this capitalistic condition. How can you get the building materials which are now produced by big industry into the rural area? But your question is about how to incorporate the rural area into the urban setting, right? So we need to separate it from the scale of urban metropolis to the neighborhood scale until the residential scale. It's incorporate different types of knowledge. One type of knowledge are coming from what we call the local wisdom or local knowledge. You can say the term. Then the government should set that this material is not a kind of temporal material. In public work, we have considered a temporal building, permanent building. It will discriminate the building type owned by the villagers. And in urban area, of course, we also get that kind of prestige by building stone buildings rather than in Bahasa Gedek, right? It's a temporal. You are subhuman if you use that material. But in rural area, you can still see so many people apply that. It's the air will flow freely from the little hole, which will protect you from the mosquitoes and so on. But that kind of material will remain the use of the vernaculars at the rural level, not in the urban, because you are not in the permanent building types or so. That's kind of classification. We discriminate the lifestyle. I think at the policy level, you need to change that term. Then you respect everybody. It's kind of what we call the inclusive development. Actually, development by the end is develop the human level, the human aspect of building or developed, rather than just develop the building, the infrastructure. So for whom? That's for the human living there, right? So we need to upgrade their standard and their status, actually. And why I call the architectural practice mostly sin. Because we usually, you guys just build what I designed for you. We never consider that, do you want to live in what I had designed for you or not? So that kind of attitude, it's a long way to go. By using that, it's kind of technological problem. It's easier than you are turning the educational system and the policy level at the government intervention for raising the construction field more widely and more justly. Possibly not the answer you want to hear, but I had to express it in front of so many intellectuals here who can enjoy this kind of good services. But it's a kind of irony. Okay, possibly that's a kind of irony answer for you.
Thank you, Prof. Thank you for highlight that. Actually, when we talk about climate change in urban areas, the urban poor is the most vulnerable, and when disaster related to climate change happen, they're the most at risk. And we see that if I have a nice houses and the flood come, rich people can move to the hotel, but for people living in a poor condition, they have to suffer more than the rest of the populations. And I believe then you mentioned that the government should fill that gap. So because most of architects serve the rich, and I also take notes that the term of vernacular in urban and rural area can be different. And if I'm not mistaken, you highlight about the participatory and inclusive. Okay, and
you're right, because we cannot direct the rich, right? They can do anything for themselves. So the government should take care of that who need real help. But don't be subverted by all of the what so-called NGO with different mission. That's why government is for, to me, but I don't know. Because the rich can do anything. They can go to vacation to Singapore, and then when you have disaster or so on. But how about the poor, those who really need your intervention and need your help? So at the policy level up to the technical level, we need to solve. It's not an easy answer.
okay. Thank you, Prof. I believe this has been tried to be implemented by the Ministry of Public Housing in slum upgrading project. Hopefully, we really can achieve the target on the slum upgrading project. And Prof. Kubota, perhaps the same question from your perspective. Yes, the vernacular in urban context. Perhaps you also can share from Japan context and also.
Thank you very much for a very nice question. So yeah, in my opinion, first of all, it is not necessary to try to apply the whole passive design technique from one building to another. Right. So as I mentioned that in the passive technique is basically each of the technique is very tiny and very simple. For instance, the deep weave, for instance, and then the permanent opening and so on and so forth. The important point is that they try to apply the multiple techniques at the same time, right? So therefore, I think what we can do is to just pick up the nice, the technique from the vernacular houses and apply it to the modern houses and combined with the other techniques also. So important is to find the optimum technique of the optimum combination of the multiple passive cooling techniques, right? So therefore, the key is passive technique itself is very tiny, but the important is to regard it as a whole system. And then, so therefore, the important is to find the best combination, optimum combination of the, specific passive cooling techniques, right? So that's an important point. So therefore, it's not necessary to try to apply the whole system from one building to another.
Thank you, Prof. Kubota. So it's not about copy and paste, but really to understand the principle of the vernacular itself, and then to really pick what we can implement in the different contexts. So understanding the context itself, I think, is very crucial in here. And I believe what you already, with your project in Tegal, is trying to implement this in the high-rise building, because your research mainly in the 2 stories building. Okay, so due to, I don't want to stand between you and lunch too long, so I guess we cannot open for more questions, but you have during lunchtime if you want to discuss further with all the speakers. Again, thank you very much, gentlemen, for the insightful presentations. Thank you. And then, of course, thank you very much. More importantly, thank you very much for all the audience for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for all the speakers and participants for your insightful question and also contribution to this session. So please remain on the stage, Bapak, Ibu, for the speakers and the moderator on these sessions, because I would like to invite Ibu Changka to please come on the stage to present a token of appreciation for our speakers and moderator and proceed with the photograph. All right, first thing first, we will allow Ibu to please deliver one token of appreciation for our moderator, Ms. Nur Hamida, Ibu Nur Hamida. And then the next one is very special for Bapak Marjuki. And also Professor Dr. Gunawan Cahyono. And the fourth is for Professor Dr. Tasu Kubota. And last but not least, we will also deliver one token appreciation for Dr. Johannes Anhorn. Thank you very much for all the speakers and our moderator. And for now, Ibu, you may proceed. Kindly please stand right in the middle, and then we will have a picture together with all the speakers and the moderator. And please give your best smile in the count of 3, everyone. From the photographer, get ready for your best shot in 1, 2, and 3. Thank you very much, everybody. And now please also give them a round of applause and highest appreciation for all the speakers again, and also for our moderator. So, ladies and gentlemen, we will now take a break for lunch and some time to mingle. So please enjoy 2 meals provided and take this opportunity to connect with your fellow attendees. We will reconvene again at 14 sharp to continue with our program. Thank you and see you after the break. Welcome back, everyone. We hope that you had a refreshing lunch and enjoyed the time to connect with each other. And now it's time for us to move on to our next session. We have an exciting lineup ahead, so please take your seats and prepare for engaging with our next speaker. We now move to our talk show session with the theme Empowering the Next Generation to Lead Initiative for Climate and Cultural Preservation. And this session will be chaired by Mr. Muhammad Nur Fajri Al-Fatah from the Ministry of Public Works and Housing, or PUPR. As many of you may recall, we had the pleasure of hearing from our next speaker during the first session, but now allow me again to highlight his remarkable qualification again. Mr. Muhammad Nur Fajri Al-Fatah is an engineer at the Ministry of Public Works and Housing, and he has conducted various research projects and development focused on energy-efficient buildings, specifically in passive cooling strategies. Currently, he is leading the SATREPS project, an international collaboration between PUPR and Hiroshima University aimed at developing models for low-carbon, affordable apartment buildings in the hot, humid tropics in Indonesia. And this session is 90 minutes, including 30 minutes discussion. Therefore, Mr. Muhammad Nur Fajri Al-Fatah, the stage is yours.
Thank you very much, ladies and gentlemen. Thank you very much for keep staying with us after lunch break. So yeah, I think this is a common, and we can see it often. There is some joke in the conference usually. So during the conference, usually after we just have a very few participants. And the speaker just say, thank you very much for keep staying with us. Oh, no problem. Because I'm the next speaker after you, okay. So yeah, that's kind of a joke when we have a conference. So yeah, thank you very much for introducing me for the Master of Ceremony. So in this session, so we have 4 energetic and attractive young generation that's probably during their works at this time in their respective institution, they working very hard for related to the climatic issues. Without any of the other two, so I'd like to introduce our speakers today. We have 4 speakers. The number 1 from the PMKG, Mr. Nugra Hinggil Subasita. Please, can you to the stage? Mas Nunu, he often so called. Mas Nunu is a climate analyst in PMKG with multi-year experience in meteorology and oceanography, receiving his master from Utrecht University. And his role is focusing in handling climate analysis for the application of disaster risk management, renewable energy, and green infrastructures. Currently, he has been advancing the machine learning adaptation in the climate events. Thank you, Mas Anu, for joining us today, this afternoon. Now, I'd like to invite the second, this is young lady, probably will be the only one lady in for our speakers. She is Miss Ifta Iradatul Utami. I think this a bit, misspelled. She just graduated from Tokyo Institute of Technology, Japan, this year. And she is engineer in Ministry of Public and Housing. She studied a lot about the indoor air quality during study in the Institute of Science of Tokyo, formerly the Tokyo Institute of Technology, since today. Yeah. Now the third presenters, I'd like to invite Kyohei Kondo from Japan. He's now PhD student in Institute Science of Tokyo. Yeah, she has been studying a lot in Indonesia, particularly since for the last 3 years here. And also he's joining our project SATREPS, focusing on the sleeping comfort. Yeah, sleeping comfort to improve the quality of life in urban Indonesia under climate change. I think this is also will be good topics, because probably nobody cares about sleeping comfort. Because as long as we don't have any burden in our life, I think we can sleep well. But I think Kondo-san will tell us more about what he found about the sleeping comfort in tropical, particularly in Indonesia. And the last, yes, Mr. Emir, he just a week ago graduated from the Institute of Science of Tokyo. Yeah. He is also an engineer in the Ministry of Public Works and Housing. As far as I know, he developed a hybrid cooling system. What is the hybrid cooling system? We will elaborate more during this session. Yeah, please, before we start the session, please give applause for our speakers. So the speakers, despite probably only a few attend this seminar offline, but I can make sure to you that more than 1,000 participants online join to hear what are you doing and what have you done in this session. Okay, let's start from, we'd like to know all of you about yourself and what have you done, or at least what are you doing until today, in particular for your respective institution in related to this, let's say, climate change, global warming, and also, yeah, climate resilience, habitat, and so on and so forth. I believe that your works most related to this kind of this. Probably, Mas Nunuk, you can start from yourself to introduce yourself and what have you done, what are you doing now for this one.
Yeah, okay, thank you, Mr. Aril. So I think Mr. Aril already introduced me enough. So my name is Nugrainggil Subasita. It's quite a long name. People usually call me Nunuk. It's much easier. Actually, I started my career as a private consultant before joining BMKG 2.5 years ago. And my topic was actually in oceanography because I graduated from ITB in oceanography before. And so started from the ocean, I end up on the land again because my last project before joining BMKG is to know the relationship between climate parameters and electricity demand. It's also that we can we saw from the presentation before from the Jonathan that most of electricity usage is actually coming from the air conditioning.
You mean Johannes?
Johannes, yeah,
okay.
Indeed, sorry. Yeah, for the air conditioning. So the temperature that I saw it's having a high relationship, high correlation with the electricity demand indeed. So that's also the reason I joined PMKG, especially in the climate Center for Applied Climate Services. Yeah.
Thank you very much. Ifta, can you add more information about yourself? And yeah.
Yeah. First of all, thank you for having me, Mr. Alin and everyone. So good afternoon. My name is Ifta Iratatul Utami, and everyone calls me Ifta. So feel free to do so. I'm an engineer, environmental engineer in the Division of Building Sciences at Ministry of Public Works and Housing. And then I hold bachelor's degree on environmental engineering. And then earlier this year, I graduated from Tokyo Institute of Technology, or as per this day, it's called Institute of Science Tokyo, because due to the merger with another university, we need to change the organization name. And then I graduated under the major of urban design and built environment, but my research focus actually, I focus more on the indoor air environment, specifically about indoor air quality. And then in correlation with the climate change, I think it is already summoned, it is already mentioned since the beginning of this event about the how climate change the human behavior, especially using the air conditioning usage. And then I want to emphasize that also the poor indoor air quality also leads to the high demand of air conditioning and also air purifier. And then these high demands of energy also can increasing the greenhouses emissions. And that's why the intersection between the indoor air quality and also the climate change. Thank you so much.
Okay, thank you, Ifta. Interesting. Kondo-san.
Okay. Thank you for inviting me as the one of the participants here. I think some of you guys want to know why I'm here. Right now, I'm from the Institute of Science Tokyo. Today is the changing, the first day for the new university. The name is changing right now today. And then right now I'm a PhD course student. Researching about the relationship between the environment and also the human behaviors. My main focus is the relationship between the environment side and also the human side. And then I get the opportunity to be involved as the, SATREP's project, so therefore I'm here. Right now, so in concerning about the human behaviors inside the residential areas, most of them does sleep inside the unit. So therefore, I right now focus on the sleeping behaviors. Except for the rural areas, maybe the rural areas is a bit different, but instead in urban areas, I focus on the sleeping behaviors. Thank you.
Yeah. Thank you very much, Kondo-san.
Hello, good afternoon, everyone. My name is Muhammad Emir Hanif Rashadi, but you can call me Emir. I was part of Ministry of Public Works and Housing in the House Development and Human Settlement Engineering under Ms. Dian Irawati, and I'm part of Subdirectorate of Building Reliability under Mr. Budi Prastowo. And I was graduated actually last 2 weeks, 20 September from Tokyo Institute of Technology, now called Institute of Science Tokyo, under the supervisor of Takashi Asawa, with the aim of creating thermal environment that is comfortable and also efficient on energy. My research is about creating a floor cooling system using hybrid cooling technology from combining passive cooling and active cooling. And also I use the PCM for the floor cooling system to store the heat inside the room and also dissipates it. And the goal is to create comfortable inside the room, and also with the utilization of the PCM and also for the energy performance of the cooling system. Thank you very much.
Thank you very much for introducing yourself briefly and what have you done during this time. So we have two fresh from the oven, so the master and one now still beginning his PhD course. Yeah. Okay, let's begin our discussion, our talk show. So first, I'd like to elaborate from Mas Nuno. Now you are handling climate data for the application of disaster risk management, renewable energy, and also green infrastructure. can you explain to us what is the green infrastructure in your point of view, and how the climate data serves the development of the green infrastructure in general for the point of view of the climate analysis?
Yeah, actually it is a question for you because actually the green infrastructure that I understand, correct me if I'm wrong. So is it the infrastructure or building that could adapt to a local climate once, and the second one is minimize the emission, can be air pollution or etc. And then the last one is the waste management, recycle, 3R. And but in the climate point of view, I think we can only answer the first two parameters, which is the local climate and then the air pollution. So just last month we actually gathered with the stakeholder, the architecture, the Green Building Council, and also academia, that we try to make our new product. It is very new. It is, and then it is in the pilot project in the Greater Jakarta region. We call it Iklim. Iklim is GB is in the green building. Iklim is climate. So it's climate information services for green building. It's actually kind of a complementary from the result that you have done with the Mr. Dewa.
Okay.
So Mr. Dewa is kind of nationwide and then also detail in the information, but we try to make it a kind of place to put on if there is a new research from the Mr. Dewa, and then we already have the place for that. So this is kind of the place that probably people can use, but now the data set is still kind of rough, but I hope in the future it will be more high resolution and then also in sense correct to any user. So the data sets we provide in Jakarta is kind of in resolution of few pages. So if you can run it, and then we have four parts. And the first part is the climate summary, and then the second part we have the detailed information regarding to the national standard for the national standard, and then the third one is to calculate the thermal transfers, the OTTV. And then and then the last one is that also you use in the building in Tegal, the windrows.
Okay.
So I think this kind of complete information that probably can be used by the architect, and then in the future we can kind of make it nationwide also. So,
okay. One more question for Mas Nono. So this is only for Jakarta, right? If I'm not mistaken.
Currently still in the Greater Jakarta. So Jakarta, Bogor, Depok, and
Jabodetabek.
Yeah,
Okay, so it means that in the future you will develop more, not only Jakarta but probably the whole Indonesia.
Yeah, the whole urban areas.
Urban area in particular, specifically. Okay, interesting. I think this is what we are looking for actually for the Ministry of Public Works. So how we make use of this kind of data from the BMKG to develop a green, this is I think one of the part of the requirements in the green building also including in this. Very nice job. I believe this is great works, and I think, congratulations, Mas Nuno. Thank you very much. Do you have any additional explanation?
I think if you go to the next, you can see in the website.
We keep that for later on.
Okay.
Okay. Because I will have a question for you for that. Okay. Thank you. Now, Ifta, I know that you have been studying a lot about the indoor air quality. I know you did some of field measurement in some of rusunaires in Indonesia. So, can you explain in detail, based on your experience and your findings of your results, how or what is the current status of the indoor air quality in the residential buildings, particularly in Rusun, right? Because you study a lot of Rusun or probably kampung, and why it's so important, and how do indoor air quality correlate to the climate change issues?
Yeah, thank you. So the term indoor air quality is actually not many people aware of it actually, and then yes, we did measurement of the indoor air quality in some apartments in several cities in Indonesia. But first, I want to show about how public awareness captured in the Google Trends in this. So I actually did research or search on the Google Trends on terms of indoor air quality. So for over 20 years span, so from 2004 until 2024. So I want to see how many people actually search this keyword on internet. And then I divided into two, the indoor air quality in Indonesia, how Indonesian or people in Indonesia are searching about indoor air quality, and also about how people in the worldwide also searching about indoor air quality. And also the third one I translated using Indonesian term, which is kualitas udara dalam ruang. And then in the worldwide, it's actually people has paid attention since even early 2000s. In the 2004, it can be seen that the spike already reached its peak, and then it keeps declining. But in the recent years, in the 2020, 2021, during pandemic, I think people start to search more about indoor air quality. However, about the indoor air quality in Indonesia, it spikes on 2015. Actually, I did some research on why 2015 has its peak on searching term of indoor air quality, and it most likely seems because of earlier that year there is an air pollution across the Asia. So I believe this triggers about the indoor air quality searching terms, and then it declines to the minimum level, and then it spikes again on 2017, and then it reached its peak around 2019 until 2021, most likely because of the pandemic also. And then because that is for the indoor air quality searching term, and for the searching term kualitas udara dalam ruangan, which is the Indonesian translation, it's only starting to reach its peak around at the 2020. It's starting to paying attention on it, and then it's because of the pandemic situation around 2020, and then it's declining now. But I think we can see how these timelines captures the public awareness regarding the indoor air quality. And also, by this, I want to move to the next slide, which is the result of total volatile organic compounds and also formaldehyde measurements. So in 2022, on the Delta Satra project, Kementerian PUPR alongside with the Hiroshima University and also Universitas Pendidikan Indonesia, we did a measurement on several apartments in Indonesia, and one of them is in Bandung, and I want to show the result on the Bandung measurement result. And then some of the measurement actually showing the formaldehyde level and also TVOC's level way exceeded the recommended limit. So we can see in this case, actually in the indoor air quality in several buildings actually is not quite good, especially for the health of the occupants, especially for the TVOC and formaldehyde, which is, I think TVOC and formaldehyde has been known for the main cause of the sick building syndrome. And also to gain deeper understanding, I would show about the map. This is the network visualization of the detected indoor volatile organic compounds actually. So we can see how some pollutants actually appears in some sources such as wallpaper, board and then from outdoor and then for walls. So we can see how these pollutants is emitted from the indoor properties. So we can see how this indoor environment could be highly affected to our health, because we almost like every day in our most time, we actually spend most our time in indoors, so we have contact a lot with these materials. And then I think it is known that climate change actually increasing the temperatures, and then the increasing temperature outdoor, it means that indoor environment will be impacted as well. And then because of the outdoor environment is impacted, the indoor we need to make adaptation indoor as well. So if we can open the ventilation because the outdoor is too hot or it's too polluted, then we need to close the windows and then we need to use air ventilating. But the air conditioning or air purifier also increasing in the energy usage. So this will be a very quite difficult loop to solve, because the climate change affecting the indoor, but indoor also contributing to the climate change as well. So this we need to pay more attention to it.
Just like, okay, thank you very much for elaborate about their research actually, and we now do understand about the current situation of the indoor air quality in Indonesia. And undoubtedly that outdoor contributes to the worsening of the indoor air quality, right? So we have to not only pay attention in the indoor itself, but we have to maintain our good outdoor environment in order to reduce the effect of the outdoor into the indoor air quality. Yeah, in particular, you also mentioned about the Indonesia, and I think, a bit worried about the current situation in Indonesia. Actually, you have some more to add?
It's okay.
Okay. Yeah. Thank you so much, Kondo-san. I'm now going to you. So you have been studying in Indonesia for the last 3 years, if I'm not mistaken, right? Firstly you study about the contact cooling, and then you now focusing on your sleeping comfort. So I'm so curious about why Indonesia. Is there any uniqueness of the Indonesian lifestyle that attract you to study it? And how do you see it compared to the Japanese, for example? And that's,
Okay, thank you for the question. The first, maybe mainly 2 reasons. First, my research is starting from the Japanese experiment, so therefore is, how can I say, from the template countries like the 4 seasons. So there are 4 seasons, summer and also winter. So therefore, they need to care about the environment more. I mean, especially summer environment. It is connected to the sleep quality and also the sleeping behaviors as well. And then after I learned it, I realized that, there is a relationship between the environment and also sleep. And then after that, I know this project, the SASRIPS project, and then when I learned it, I found the research from Professor Kubota that saying that the opening windows, and it is happening in the daytime, and but instead in the nighttime it is not happened, and also they, how can I say, the most of the time that they use the AC is the only nighttime. Yeah, so mainly the time that they sleep is the time that they use the AC because of the security, privacy, and also the mosquitoes in the nighttime. So therefore they need to close the windows. So inside, that is so hot. So I think it is because of that they start to use the AC in the nighttime only. In the daytime, they can get the airflow, and also if they go outside like the corridor areas, they can get the wind, and then they can feel comfortable even they feel hot. And then they, in that result, I assume that maybe if they don't use AC in the nighttime, they feel so hot. So therefore, maybe their sleep quality is a bit worse than the AC users. And so therefore, I start to research. This is the first, how can I say, reason. And the second reason is as for the physiological responses, it is totally different from the temperate countries people and also tropical countries people. As for the core temperature trends, they can, how can I say, release the heat. I mean, the tropical countries people, they can, how to say, release the heat from the body so easily compared to the temperate countries. Because if the temperate countries people release the heat so fast, in the winter season, they feel too cold. So therefore, their core temperature trends is, how can I say, fluctuation is smaller than the tropical countries people. In the nighttime, their core temperature, tropical countries people's core temperature is so decreased, and then release the heat, and then they can sleep easily. And also, their sweating rate is smaller than the Japanese or the Europeans, actually. So in Japan, in the summer season, if they don't use the AC, they sweat a lot. So therefore, it disturbs their sleep quality. And also, how can I say, it is so difficult to sleep as well. But instead, in the tropical countries, people, they don't sweat so much, even in the nighttime, I guess. So therefore, I assume that it is, how to say, key factor to, how can I say, not to disturb their own sleep quality. Yeah, that's the reason that I research right now.
Yeah, you spoken a lot about you talk a lot about the thermoregulation, body thermoregulation and physiology. Did you consider about for example, the cultural differences, for example, why you so interested in Indonesia in particular, for example, as you know that, yeah, probably most of Indonesian people are Muslim, and they wake up at early morning 4 a.m. or something, and they sleep earlier, or probably others. And yeah, other than that, probably there are also a lot of the cultural issues, differences between the Japanese and also the Indonesian that might you be consider in your research.
Thank you so much. Maybe that one is the next step that I need to clear. But instead, the thing that I know is as for the sleep quality, it is connected to the sleep duration as well, right? And then I found the research that they said that even, how can I say, they split the sleep because of the praying. If they, how can I say, sleep more than 7 hours or so, it is the quality, I mean the perception of the sleep, sleep satisfaction is same as the people who sleep, how can I say, overall 7 hours, not split. So therefore, so far, I assume that that one is also affected. But instead, if, how can I say, they sleep again after praying, for example, maybe their sleep quality is not so different, maybe. So therefore, it is an interesting thing. In another way, sorry, yeah. Maybe that's not the one that you expect. So. But instead, yeah, it's like that. Thank you.
I believe you also consider about the economic matters, right? Because I myself, if I don't have money, maybe I cannot sleep well. So yeah, Emir. So now you are trying to, let's say, now I believe that you have developed a hybrid system, combination of active and passive cooling system, right? And I believe you are now still developing, right? Because I believe that your previous results still need to be improved, right? To improvement. So can you explain in detail what is the hybrid cooling you have conducted during this time, and how this efficiently reduce the energy and let's say impact to our fighting against the climate change, for example. Yeah.
Thank you very much for the questions. So in this research, I make a combination of passive cooling and active cooling, but I use it in the integration with the floor cooling system. So in here, we made elevated floor. So from the original floor, I elevating it around 15 centimeter to install the AC in the floor level. We usually install the AC in the ceiling level to cool the room, but in here we install it in the floor level. This is because we want to cool the floor level and to use the cascade cooling. Cascade cooling is to, in here the bedroom and the living room is connected, and therefore the AC that will be turned on can cool both the bedroom and the living room during nighttime. And the feature of the system is I use PCM, and that is what's installed in the living room to absorb the heat during daytime and increasing and reducing the temperature, therefore increasing the comfort. So PCM here, called the phase change material, is a material that can absorb heat and then dissipates it. And to absorb heat, it will change the phase from the liquid to frozen. So from frozen to liquid, it will absorb heat and then melting it. And then when it is cooled, it will release the heat. So it will from the solid back to the liquid. So using the concept, the PCM will store the heat during daytime, to absorb heat during daytime in the living room. And then when it is nighttime, from the AC and also the fan that was installed in the living room, it will cool the PCM, therefore releasing the heat and changing the PCM back to the solid. And also this cooling devices installed at the floor level and reducing air conditioned space, and therefore it lowered the energy consumption. And then, so this is like the picture of my research. I have done this research in Tegal Experimental House. Thank you to Kubota Sensei for the giving the room here. And this is the bedroom and the living room. So as you can see, in the bedroom, the AC is installed in the floor level, and while in the living room, there's a fan installed also in the floor level. And in the bedroom, this is the floor cooling without the PCM, while in the living room, it is installed using the PCM. So the AC and fan act as the cooling devices, where AC is the active cooling and fan is the passive cooling. So why I still use the AC? Because to reduce the energy consumption, we cannot cut completely off the air conditioner. So I want to know how to reduce the energy consumption. Therefore, I installed the controller that detects the outdoor temperature, so that when it reaches certain temperature, the AC will turn off and then go back into the fan. So this is the control logic that I use. So the AC and fan are operating during nighttime, 6 p.m. to 6 a.m. And there's a sensor. When the outdoor temperature reaches certain temperature, in my case it's 26.7, above the 26.7, the AC will turn on. But when it reaches below the 26.7 degrees Celsius, the AC will turn off and then it backs to the fan. And then when it is daytime, it reaches 6 a.m., these cooling devices will turn off. And then next is the result of the thermal comfort from this system. As you can see, there is bedroom, living room, and reference room. The reference room is indicated by the yellow one, is where the room without the floor cooling system. So it is normal room to compare with the floor cooling system and without the floor cooling system. And as you can see, during daytime, reference room almost reached 33 degrees Celsius high, while the bedroom and living room installed with the floor cooling system only reached 30 degrees Celsius, while the living room, indicated by the blue line, it's during daytime, 6 a.m. to 6 p.m., it almost below the 30 degrees Celsius, while during nighttime, bedroom and living room cooled by the AC and the fan, it can reduce the temperature. So therefore, in this case, thermal comfort during daytime has increased using this hybrid floor cooling system compared to the reference room, as you can see. And daytime, with the addition of PCM installed in the living room, it manages to reduce temperature during daytime, thus increasing the comfort time. And then from the energy consumption perspective, so I also use the fan, AC, and controller. The difference of this case is the fan is turned on during nighttime, 6 p.m. to 6 a.m. without stop. And case 3, AC turned on during nighttime without stop, 6 p.m. to 6 a.m. And then case 4 controller is using the controller to change between the AC and fan. While case 5 is open window, I open the window in the living room. And from here, it was found that case 3 AC, using the AC turned on during nighttime, it was the high energy consumption. But by using the controller that changing between the AC and the fan, it can reduce the energy consumption from 21 to 55%, and also it can lead to high coefficient of performance. Therefore, with the help of the controller, so to switch between the AC and the fan, energy consumption of the cooling devices can be reduced, and from previous result, it was found that it can still maintain the thermal comfort inside the room.
Okay, thank you very much, Amir. So basically, as we understand that using hybrid cooling, we can reduce more energy, right? Compare if we just only apply the passive cooling. Is that true?
Yeah. So passive cooling, as we all know, have a limitation that it is very reliant on the microclimate of the buildings. Well, that's why I use AC to still maintain the comfortable inside the room, but from the data from microclimate from the buildings.
Okay. Now you are still going to develop this system, right?
Yeah, hopefully.
I think Ibu Ira will support you to develop this system in the future, because this is very beneficial for cooling system in Indonesia. Thank you, Emir. Now we back to Mas Nono. So yeah. BMKG, Pusian Klim, and also you, I believe that now are develop an information system of applied climatic services for specific purposes. Now you can explain to us about that services provided by the BMKG for the infrastructure in particular.
So to answer that, actually, we have to start explaining about what BMKG is. So BMKG actually have 4 tasks. It's in my point of view. The first one is the mandatory observation, and the second one is analysis and forecast. Also projection. That analysis is something to go back, and then forecast and projection is something to go further beyond today. And then the third and fourth, it's actually something that we derive from the first and the second task. This is that we try to develop in my center. It's a Center for Applied Climate Services. The third one is I call it. It's not a term in BMKG actually. So I call it to avoid something negative from the climate. So because from the forecast we can see the potential disaster, so we give so-called early warning for everything, for all. This is early warning for climate, early warning for weather forecast, and etc. Also the earthquake. And the fourth one is something that we could kind of benefit from the weather and climate. That's also that we do together. This is to consider microclimate, to emphasize that benefit from the climate to increase our life quality. That's also that we provide here. I joining in the team so-called climate for infrastructure, actually, in the climate services. And then we try to develop not only this for infrastructure, it's also from the flood forecast, it's from the disaster point of view. And then we also have product for renewable energy. That is also, this part is from the positive side point of view. and the other one is this one, the infrastructure.
Infrastructure.
Yeah, so this is, we use information from any kind of sources that we can do, from reanalysis model, satellite images, and also ground observation also actually for the precipitation. And also this is there, we have also information for outdoor air quality actually. So if indeed in the beginning I'm wondering how can, because in the regulation from the Ministry of Public Works, it's about, for the green building is about indoor air quality, but we don't have any measurement for indoor quality. So I try to find out, is it outdoor quality could be related to the indoor quality that Ms. Ifta already said is indeed, it is usable, and then so I hope this will be usable, because we have also information about the PM 2.5 for the air pollutant, also gases. We also provided the NO2, because NO2 is kind of pollution for the vehicles. So I think this is important. And yeah, and also it's a bit difficult because the air pollution and air quality that we usually consider is something in the surface, but we still lack of observation in the surface, also modeling. So, but in this platform, I use information from satellite, but it's column-wise until tropospheres. So it's not really good in the number, but in the term of variation, I think it can be used, because there is a variation also in the seasonal variation.
Okay, but as we can see the pattern from the satellite.
Indeed.
Okay.
Indeed.
But the number we can produce
I think
later on.
it needs to be corrected from the number.
I see. So now we understand that probably in the future, IFTA and you can collaborate more for developing this system, because it's very interesting to develop in the future. And I believe that will, maybe our suggestion to PMKG team is also we need to develop the information on outdoor air quality, so that we can forecast indoor air quality in the such area. Okay, thank you very much, Mas Nunu. Now we go to the IFTA again. In one of your study, you including the regulation point of view for the regulating indoor air quality. In your opinion, so in Indonesia, do we already have pay more attention to the indoor air quality issue based on your findings? And do you find that the regulation adequate, at least to regulate the indoor quality? And how we improve if, based on your experience, that, this is not sufficient, so we have to improve more in this part, And what do you think?
I think in terms of regulation, I discussed a lot with a lot of stakeholders, including our seniors in the Ministry of Public Works, and also the one that is quite responsible for the occupants is Ministry of Health. In my view, I think I'd say that we have not yet paying enough attention on the regulation. First of all, because the existing regulation, we aware that we have a regulation regarding the building efficiencies as a green building, and also this year I believe that we released a new standard on the ventilation. But I think we need a comprehensive regulation on the healthier living environment, for example, in the pollutant inside the building. And then I also realized there is a gap between the government bodies. For example, when we talk about the building, then we have responsibility, we as a Ministry of Public Works and Housing. But when we talk about the indoor air quality, which is related to the human being, to the human well-being, then it is the occupant inside the building that we regulate it. So it's the person. When we're talking about the person, then the one who is responsible is the Ministry of Health. So I think we need to pay this kind of gap, and then we need to paying to the further concern about this one. But I think this is not a disadvantage. I think this is a very huge opportunity for us, so we can work together. We can collaborate together to make a holistic regulation regarding the indoor air quality. And then for the improvement, I think it is quite tricky because when we talk about the regulation and we talk about the bureaucracy, but the things that I want to point out is two main things. For the first one is so far, especially the regulation that is related to the indoor air pollutants, is stated by Minister of Health. I think we still adapted from the foreign regulation, and then I think we need to make our own regulation based on the evidence-based measurement. So as Pak Nunu said before, we lack the data of the measurement of the pollutants, outdoor as well as indoor. So we need to map all the measurement data across the Indonesia if it's possible, and then we make regulation based on that. So we make an evidence-based regulation.
Okay, thank you. So if I may, to highlight, so we have to develop our own regulation, not only just adopting.
Yes.
Wow, that's very tough.
Yes, it is very tough. And then I think the other one is also tough.
Yeah. I think this is long, you know, like, very.
Yes.
Yeah.
And then actually, aside from the evidence-based regulation, I think one of the challenges is to the enforcement.
Of course, yeah.
The enforcement,
yeah.
yes.
That's what we need exactly, evidence-based policy.
Yeah.
And we hope, we are moving toward to the evidence-based policy.
Yes.
Okay, Kondosa. So, it is interesting that you study a lot about the sleeping comfort in Indonesia. So please tell us more about your findings during your current research in Indonesia about the sleeping behavior of Indonesia, so we Indonesian can understand what our behavior in sleeping actually.
Okay. Yeah, thank you. And so maybe I need to explain about the reason why, how can I say, the sleep quality is important in our life, of course.
Yeah, of course.
There are several reasons. The first, we cannot do the daytime activity without sleeping. So therefore, the functionality of the sleep is taken less. And then getting the, how can I say, recovery. And then after that, it is also connected to the mentally well-being as well. And also based on the sleep quality, that we can focus more, I mean, in terms of the productivity in working, for example. So therefore, it is so important to research about the sleep quality, even in, how can I say, tropics as well. But instead, there are a bit few researches about the, how can I say, the actual conditions so far in Indonesia and also in the tropical areas. So therefore, first I did the field measurement for the university students in Surabaya and also Bandung for 41 students, 41 subjects. In actual bedrooms, I put the sensors for the summer environment, and also I did the survey as well. And then the first thing is about the, based on the, how can I say, summer environment, in this case, the average indoor air temperature during nighttime, during sleep, the proportion of how can I say, the cooling methods is totally different. Especially for the Surabaya, it is, how to say, there is a border of whether they use the AC or they don't use the AC, and also they just use the fan or they just open the windows, especially with the more than 29 degrees Celsius during nighttime. In previous studies from the Japan and also China, Korea, and also Europe, they propose the, how can I say, appropriate temperature during sleep. It is from the 17 degrees Celsius until 28. So therefore, as for the 29, more than 29, actually it is exceeded from the proposed how can I say, not the regulation, the standard that is for the good sleep. So therefore, I assume that maybe these kind of people, how can I say, get the worst sleep quality. But instead, next slide. But instead, it's not like that. The first of all, about the summer comfort. During sleep, it is not possible to get the data, from the subject. So therefore, it is divided into two. So before sleep and also after I wake up, light before sleep, I ask the subjects to answer the questionnaires, and also light after wake up as well. So before sleep, of course, in the higher temperature conditions, they answer the hot and also uncomfortable before sleep. And also as for the lower temperature with the AC condition, they answer the cool and also comfortable as well. It is common, I guess. But instead, as for the after wake up, it is so interesting point that I want to tell you. As for the lower temperature conditions with the AC usage, they answer the cool, but instead uncomfortable actually. So therefore, they feel too cool, too cold with the uncomfortable sensation. So therefore, actually, after wake up, the temperature, at least as for the temperature, it is not appropriate for their summer comfort. So it is the important point. And also the next one. Next one is as for the sleep efficiency. Maybe I need to explain as well the indicator. That one is from the smartwatch. I calculated the sleep efficiency is that during the sleep, actually they wake up. So there is a time that they wake up. From the brain wave. So therefore, calculate the perception proportion of the actual sleep stage during the sleep condition. And then if that one is higher, they don't get awake, so therefore it is a good thing. So if the high value of the sleep efficiency is a good thing. But instead, as for the Slavaya, even the temperature is different in the AC condition and also non-AC condition, the sleep efficiency is not so different actually. And also the point is, as for the, the way of using the clothes and also blanket during sleep. So as for the sleepwear, maybe there is a legend that is a continuous legends. And then even the AC users, their sleepwear is similar to the non-AC users. Yeah, as you can see. But instead, as for the blankets, it is totally different. So especially for the Slavaya, it is so obvious. AC condition, they use the thicker blanket than the non-AC users, like a duvet or something. But instead, as for the non-AC users, they don't use the blanket or maybe the thinner one. So it is, maybe the reason why the non-AC conditions can maintain their sleep quality. Yeah. Right now, in my mind, it's like that. So it is connected to the summer adjustments. So, and also we can do the summer adjustment by ourselves if we can focus on that. So therefore, I want to say that the summer adjustment is connected to the sleep quality as well. Yeah, that's the thing that I want to tell.
Okay, you were talking about the thermal adjustment during the sleeping time, right? So my question is, did you consider about not only thermal adjustment, but also, adaptation behavior? For example, okay, if this is too hot, when I cannot handle it with even if I open the windows and using fan, but still hot, so probably I will take off my clothes. And I just sleeping with, in Indonesia, yeah, not naked or but half naked. Yeah, just take off my clothes. Yeah, but I still use sarung, for example. Did you consider about that? How? Yeah, probably in yeah.
Yes, that is, how can I say, connected, because as I showed before, so more than the 29 degrees Celsius, they use the fan and also windows, right? And then they don't use the blanket so much. So therefore, in my perspective, it is so, how can I say, beneficial for the release from the body, release the heat from the body. It is called the heat dissipation. I mean, during nighttime, during sleep, their appendages like the hand and also the foot, the skin temperature is getting increased. It is for the heat dissipation from the body to the environment. So therefore, if we use the fan and also windows, we can get the airflow, right? So the airflow is connected to the convection. So therefore, the heat convection is higher, and then their body heat is so easily to remove from the body.
Okay, yeah.
So therefore, it is also, how can I say, much with their thermal adjustment and also the thermal, how can I say, cooling methods. But instead, as for the AC users, actually, it is because of the how can I say, the thermal perception in the waking time, because before sleep, we set the AC and then sleep, right? So therefore, the condition of the before sleep is, how can I say, make us to decide the cooling method. And then if in the awakening time, in the tropics, comparing to the Japanese or the European, the thermal sensation that makes us feel comfortable is the cool side. So therefore, from the hot environment, they want to get the cool environment for getting the thermal comfort. So therefore, they set the AC, but instead, during sleep, the core temperature is getting decreased. So therefore, in order to maintain the core temperature with the AC condition, they need to use the blanket so much compared to the no AC. But instead, it is, how to say, not, it is reasonable, but instead, it is not much with the characteristics of the tropical countries. Yeah, that's the relationship.
Yeah, thank you. Why I'm asking this, because as you know, probably my Indonesian fellow, sometimes we have a strange behavior. If we sleeping under the air condition system, we just set the thermostat very low. But when we feel cool, so we just pull off our blanket instead of increasing thermostat, right? So because it is easy for us, just okay, pull up the blanket instead looking for where's the remote, just we can proceed with our beautiful dream, right, during the night time. Okay, thank you very much, Kondosan. So, okay, Amir, you already explained about your system. My question is quite simple. So, if this system is going to be applied in Indonesia, so what, in your opinion, what is the main challenges of implementation of the system in Indonesia?
I think the main challenges for the system to be applied to Indonesia is how to utilize the PCM and to construct the floor cooling system into the residential unit. So in my case, during daytime when PCM absorbs the heat, for the controller when it is closed during the nighttime, the window of in the living room, in the balcony door, the heat that was absorbed from the PCM is quite low compared to the case 5 where the living room balcony window is open. So from the graphics, we can see during daytime the heat absorption from the case 5 is higher than the case 4. And this also affects the heat dissipation during nighttime when the case 5 is still higher than case 4. So the utilization of the PCM in this system needs to be considered, how to maximize it. And also, this condition is also still in the development phase, and no mimics real life condition. As we all know, in the living room, we use many furnitures like sofa, TVs, and maybe in the kitchen we do activities and humans. In here, still empty, so no heat generation devices that was installed in this unit, in this case. And in my experience, when I step on this floor cooling system, the ceramic is easy to crack, because I'm also a heavyweight, and this foundation is built on the simple material using red bricks, so it has a weight capacity. So in order to fully apply it, so it will need a stronger floor foundation, so that people that will do activities above this elevated floor, so they can do activities freely and do not broke the floor cooling system.
Okay, so you have to lose your weight. Let's lose our weight together.
Yeah,
right?
hopefully.
But I think my simple question for you, Emir, where can we buy the PCM in Indonesia?
That's a hard question.
I think that's the main challenges of implementing your system, right?
Yeah. PCM is flammable, so it is. In this research we use paraffin.
Yeah.
So it is
That's
very flammable. So
Okay.
so the safety aspect of the system also needs to be considered as well. Yeah.
And the second, I think, is select the appropriate, the best, PCM, because we have to carefully select the melting point and also,
melting and freezing temperature. In my case, because Rusun Tegal is designed with the good passive condition, so during daytime, it didn't reach the melting temperature of the PCM. In my case, PCM is 29 degrees Celsius, but in my research, the floor didn't reach 29 degrees Celsius.
Okay, thank you very much, Emir. Please give applause for our 4 speakers. Yeah, actually, I myself still have several questions, but unfortunately, we have running out of time for this session. So we are going to Q&A. So anybody have questions for these young ladies and gentlemen? How about the online participants? No? Okay. If no, I think I can proceed with one question for each of you before we closing our session today. So, yeah. What is your plan for the future of your respective tasks? Right? For example, Emerson, you will, I will develop more and more. So this is, and maybe I will make my own PCM by using local material, for example. Yeah. What is the future? Let's start from Emir.
For the future, short term, I will continue working in the Ministry of Public Works and Housing, and also supporting the SATREF project. And hopefully, we can implement this floor cooling system in the real life condition, so that maybe we add some furniture or some heat generation devices and stronger foundation in the floor cooling system. And so that we know how to apply this in the future and know the positives and more negatives and the profile of the floor cooling system.
Okay, so Kondo-san, I think you have asked me to show something about QR code. Okay, please show the.
If possible. I mean, at first I explained about the future plan that I want to do. First, I did the field measurement, but instead it's not the experiment. So therefore, I want to explore say, the effects of the blankets itself and also the relationship between the fan and also window. It is also necessary as well. And then based on that, maybe we can develop the new devices or the new systems to, how can I say, to obtain the good sleep and also the healthier life as well in tropics. Maybe for the temperate countries, maybe the air conditioning is the best way during sleep. But instead, from my results, maybe I assure that maybe we can develop another devices that is possible to obtain the good sleep as well. And then it is connected to the thermal behavioral adaptation. It means the way of using the blankets or the sleepwear. So therefore, sorry, right now I understood that the team try to develop the new not the sleepwear, but the clothes that is applicable for the tropical countries. So therefore, if you are interested in, please join the survey from the QR code. You can see the survey. So therefore, if you are interested in, please join it. And also, I want to do the collaboration with the another aspects as well. So therefore, yeah, that's the plan that I have right now. Thank you.
Oke, jadi Bapak Ibu silahkan di-scan baik yang hadir offline maupun online untuk membantu Kondo dalam penelitiannya ya. So please ladies and gentlemen, if you have if you don't mind, please scan this QR code and then fill out the questionnaire for Kondo-san. Yeah, go ahead, Ifta.
Yes, for the future plan, I think as the continuation from my previous work, I would like to, if I given the opportunity, I would like to map all the current status of indoor air quality across the Indonesia and across for all building types.
Oh, that's great. Okay.
Because I think every available references right now, I found a very limited references on the indoor air quality condition. It's limited to the school and residential buildings, but not for the commercial and other buildings as well. And also, I would like to do cross-discipline collaboration. I mean, every speaker here, like Panunu for the climate, sleeping behavior, and then the hybrid design. I believe that we can, there's something that intersect between our field, and then we can do collaboration. It would be great. Even with the, for example, like social science also will be very, very great for that. And yeah.
Wow, now I can imagine that you develop research that you are sleeping in a hybrid cooling system room, considering the indoor air quality. Wow, that's very good collaboration. But where is Mas Nuno? So what's your plan actually?
Yeah, regarding to my plan, I'm not preparing.
So you will join three of them? Or you will working alone?
Because actually our in climate service information is still use a kind of mesoscale resolution model, but I found out myself, I experienced myself when I riding through the Jakarta and near the skyscraper, and actually there is kind of a extreme wind sensation, a strong wind breeze between the skyscraper and the wind tunneling effect that we kind of cannot capture from our data, so probably we have to build a new data set. This is kind of a high resolution. That's, we are trying to, I'm trying to actually at least. And then in my experience also I kind of to use the machine learning, because if we do fully and the full time scale of climate for a high resolution model is really
that's billion data,
costly,
right?
and then takes probably more than 30 years each time. So I think I'm trying to utilize the machine learning so we can try to what kind of create the kind of typical meteorological year that probably can be derived from that in high resolution, but it's not by the simulation.
That's great. Yeah, that's great. But I personally hope that the strong collaboration between PUPR and PMKG being maintained, particularly for the climate service for the green building. I think that's very necessary for us because some of the requirement in the fulfillment of the green building very, needs to consider the climate condition carefully. So we need to as accurate as possible the climatic data to determine, okay, this is comply with the standard, this is comply with this regulation and so on and so forth. So thank you very much, Mas Nuno. You have some additional comment?
It's regardless from the context because we are from the MK, kind of try to encourage everyone to do your climate action because we see in the CFC that produce the ozone hole is actually started during the Montreal Protocol in 1991 and then kind of 3 to 4 years ago, and then the ozone hole kind of recovered. So something that started more than 30 years ago is actually kind of begin to have in the result in the term of 30 years. So if you have something that you can start now with your climate action, start now because what you can harvest it not for you but your next generation. Something like that.
That's maybe the wise statement for today. We have to consider our next generation, right? I believe you will soon have children, kids, so you have to to consider about the future of your children. Okay, is there any question from participant online or offline? It seems still no question. Okay, time is over. Okay. We have run out of time, so unfortunately our very fruitful discussion to end. But believe me, this is not the end of the discussion, but only in this session. But after this, we can continue our future collaboration. Thank you very much. So I may not conclude anything for this session. So just I ask your big applause for our great speakers. Once again, thank you very much, Emir, Kundo, Sang, Ifta, and Mas Nunu. And now I'm returning to the Master of Ceremony. Thank you.
Thank you very much for our moderator, Bapak Muhammad Nur Fajri Al-Fatah, and also for all the panelists for engaging and inspiring discussion and the lively discussion as well. Was such a great talk show. So everybody, again, we can give a round of applause for our panelists and also the moderator. And please remain on the stage, Bapak Ibu, for the speakers and also the moderator, because just now I would like to invite Ibu Dian Irawati to please come on the stage to present a token of appreciation for our speakers and moderator, and also proceed with the photograph. And the first token will be delivered to our moderator, Bapak Muhammad Nur Fajri Al-Fatah. And also the next one is for Bapak Muhammad Bapak Nugra Igil, dan juga selanjutnya we'd like to deliver it for Ifta Irodatu Utami, and also for Kondo-san, Kyohei Kondo, and the last one is Emir. Alright, so now we'd like to proceed with the photograph in the count of 3 with all our friends. And for the photographer friends, in the count of 3, and 1, 2, and 3. And that's a wrap. Thank you very much. Thank you very much again, Ibu Dian Irawati. And also, Ibu Dian, please kindly take your place for... Oh, okay. And also, I would like to again deliver our gratitude for all the panelists. And now, we'd like to have another photograph again. Yeah, and 1, 2, and 3. And that's it. All right, thank you very much. And Ibu Dian Irawati, please kindly have your place on the stage, because in the meantime, we would like to invite you back again for delivering a closing statement. So ladies and gentlemen, we officially conclude that our international seminar on paving our sustainable future, innovation in climate resilient habitat. Thank you very much for all your participation and contribution. We hope that the insight shared today will pave the way for a more sustainable and resilient future for all. Hadirin yang kami hormati, kini telah tiba kita saatnya di penghujung acara dan juga merupakan kehormatan bagi saya untuk dapat menyambut kembali Direktur Bina Teknik Pemukiman dan Perumahan, Direktorat Jenderal Cipta Karya Ibu Dian Irawati untuk dapat menyampaikan sambutan penutupan acara. Kepada Ibu Dian Irawati, dipersilahkan.
Terima kasih kepada moderator, pembawa acara, yang sudah memberikan kesempatan saya untuk menyampaikan sambutan penutup pada acara Seminar Internasional Habitat dan Peluncuran Peta Zona Iklim untuk Pendinginan Pasif dan Data Iklim Standar dalam proses pembangunan gedung berkelanjutan. Bismillahirrahmanirrahim. Yang saya hormati Bapak Menteri Pekerjaan Umum dan Perumahan Rakyat, Bapak Dr. Insinyur Muhammad Basuki Hadi Mulyono M.Sc, dalam hal ini diwakili oleh Bapak Sekjen Kementerian PUPR, Insinyur Muhammad Zainal Fatah. Yang saya hormati Kepala BMKG, Ibu Profesor Insinyur Dwi Korita Karnawati M.Sc PhD, dalam hal ini diwakili oleh Deputi Bidang Infrastruktur Meteorologi, Klimatologi, dan Geofisika, Dr. Ing Michael Andrea Purwadi. Yang saya hormati Bapak Ibu Pejabat Tinggi Madya dan Pratama di lingkungan Kementerian PUPR dan juga BMKG. Yang saya hormati pembicara kunci Prof. Gunawan Cahyono, Prof. Ted Sukubota, Dr. Reinhard Johannes Anhorns, Ibu Moderator, Ibu Nur Hamidah, dan juga yang saya banggakan tentunya di sini adalah pembicara talk show Pemuda-Pemudi PUPR dan BMKG serta Tokyo Institute of Japan. Dan tentunya juga yang saya banggakan para peserta acara berbahagia yang sudah hadir di sini untuk mendengarkan knowledge sharing dari teman-teman yang ikut dalam penelitian SATREPS. Assalamualaikum warahmatullahi wabarakatuh. Salam sehat dan salam sejahtera untuk kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Pertama-tama marilah kita panjatkan puji syukur kehadirat Allah Subhanahu wa Ta'ala, Tuhan yang Maha Esa, karena rahmat dan ridhonya kita dapat menyelesaikan acara pada hari ini dalam memperingati Hari Habitat Dunia dan Hari Kota Dunia, sekaligus peluncuran produk hasil kolaborasi internasional antara Indonesia dan Jepang berupa peta potensi pendinginan pasif dan data iklim standar. Acara yang telah berlangsung sepanjang hari ini telah memberikan banyak wawasan yang sangat penting bagi kita semua dan diskusi yang sangat produktif dari berbagai sumber dan para narasumber pemuda-pemudi yang menunjukkan pentingnya inovasi serta kolaborasi dalam mengembangkan infrastruktur yang berkelanjutan dan tahan terhadap perubahan iklim, khususnya di sektor bangunan gedung. Kita semua menyadari bahwa tantangan perubahan iklim semakin nyata dan mendesak Kami sangat menghargai kolaborasi antara Kementerian PUPR, kemudian BMKG, Kagoshima University, kemudian Hiroshima University, serta dukungan penuh dari JICA yang telah berhasil melahirkan inovasi berupa peta dan data iklim yang dapat membantu kita merancang infrastruktur yang lebih tangguh terhadap perubahan iklim. Bapak Ibu yang saya hormati, data iklim yang akurat memainkan peran yang sangat krusial dalam perancangan bangunan yang hemat energi dan berkelanjutan. Peta potensi pendinginan pasif dan data iklim standar yang kita luncurkan pada hari ini memberikan informasi yang sangat penting bagi kita semua untuk mengoptimalkan desain bangunan. Dan dengan ini kita dapat merancang bangunan yang sesuai dengan kondisi iklim setempat, mengurangi ketergantungan pada alat pendingin, mekanik ya, seperti AC, serta meningkatkan kenyamanan penghuni. Kolaborasi yang melahirkan inovasi ini adalah bukti nyata bahwa sinergi antar lembaga baik di dalam dan luar negeri dapat menghasilkan solusi yang efektif dalam menghadapi tantangan global seperti perubahan iklim. Kerjasama ini juga menunjukkan bahwa kita tidak dapat bekerja sendiri ya. Inovasi dan pembangunan yang berkelanjutan membutuhkan komitmen dan dukungan dari semua pihak. Hadirin yang saya hormati, sektor bangunan merupakan salah satu kontributor terbesar terkait emisi gas rumah kaca, namun juga memiliki potensi signifikan untuk penghematan energi. Melalui penerapan strategi desain pasif, efisiensi energi dapat ditingkatkan secara signifikan seperti diamanatkan Permen nomor 16 tahun 2021 tentang peraturan pelaksanaan undang-undang bangunan gedung dan peraturan Menteri PUPR nomor 21 tahun 2021 tentang penilaian kinerja bangunan gedung hijau. Kami menargetkan bangunan untuk bisa mengurangi konsumsi energi sebesar 25% selama beroperasi. Peta potensi pendinginan pasif ini sangat membantu implementasi kebijakan tersebut dengan lebih baik. Bangunan tradisional Indonesia yang responsif terhadap iklim juga memberikan inspirasi bagi kita semua. Kita dapat belajar banyak dari arsitektur tradisional yang telah menerapkan strategi pendinginan pasif yang sesuai dengan kondisi iklim setempat ya. Tadi seperti yang disampaikan Prof. Kubota, ini juga bangunan tradisional yang ada di negara lain ya, seperti di Malaysia gitu ya, di Penang seperti itu juga sama ya dengan kondisinya dengan di bangunan tradisional di Indonesia, ini menggunakan pendinginan pasif ya. Namun membawa strategi desain ini ke konteks perkotaan ini tentunya memerlukan inovasi dan penyesuaian termasuk ke dalam pemilihan material yang lebih efisien dan teknologi modern. Sebagai langkah selanjutnya penting bagi kita untuk memastikan bahwa semua pengetahuan dan data yang telah kita peroleh pada hari ini diterapkan dalam proyek-proyek infrastruktur di seluruh Indonesia. Ini berarti integrasi peta potensi pendinginan pasif dan juga data iklim standar dalam setiap tahap perancangan dan pelaksanaan proyek ini dapat termaksimalkan potensi untuk efisiensi energi dan berkelanjutan. Hadirin yang saya banggakan, semua yang telah kita capai pada hari ini adalah awal yang baik untuk langkah-langkah yang lebih besar di masa depan. Saya berharap acara ini menjadi inspirasi bagi kita semua untuk terus berinovasi dan berkolaborasi demi pembangunan yang lebih berkelanjutan dan tangguh terhadap perubahan iklim. Terima kasih yang sebesar-besarnya kepada semua pihak yang telah berkontribusi dalam menyukseskan acara ini, terutama kepada para narasumber dari BMKG, Kagoshima University, Hiroshima University, serta JICA atas kerjasamanya yang luar biasa, dan juga tentunya terima kasih juga kepada seluruh panitia yang telah bekerja keras untuk acara ini, kepada tim Balai KPP, Balai Sains, terima kasih. Dan juga mengucapkan alhamdulillahirabbil alamin, saya secara resmi menutup rangkaian acara dalam rangka Hari Habitat Dunia dan Hari Kota Dunia, dan juga peluncuran peta potensi pendinginan pasif dan data iklim standar. Terima kasih atas perhatiannya dan partisipasi Bapak Ibu sekalian. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Kami ucapkan terima kasih kepada Ibu Dian Irawati atas sambutan penutupan yang telah disampaikan. Hadirin sekalian, dengan demikian kami resmi menutup rangkaian acara Seminar Internasional Paving Our Sustainable Future, Innovation in Climate Resilient Habitat. Terima kasih atas partisipasi dan juga kontribusi Anda semua. Kami berharap wawasan yang dibagikan hari ini akan membuka jalan menuju masa depan yang lebih berkelanjutan bagi kita semua. Akhir kata, saya Azarumi pamit undur diri. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Selamat sore dan sampai jumpa di acara mendatang.